Good morning, everyone. It is 9 o'clock. We will give everyone a minute or two to finish logging in, and then we will get started. morning, and welcome to our final day of the 2022 ELAP Conference. I'm Jen McLaren, Conference Co-Chair, and we are glad you have joined us this morning. Our first 3 days have been filled with great presentations and thoughtful Q&A sessions. If you happen to miss any of those days, we invite you to watch them on the ELAP YouTube channel. There's a link to the YouTube on our conference webpage, as well as in the chat box here, which we'll post in just a minute. If you've joined us this past week, you probably have my opening memorized by now, but just in case we have a few people here for the first time, I'll go over the basics one last time. We're using Teams Live to accommodate the large number of attendees. As an attendee, you can't unmute yourself or turn your camera on. Any questions you wish to pose to our presenters can be done through the Q&A chat box. We encourage you to put your name in the space provided. On your screen, you should see how to submit your questions via chat. During today's event, feel free to send in your questions throughout the morning at any time. We'll pose the questions to our presenter at the conclusion of her presentation. We also invite you to join in on our conversation on the Slack channel. We have had a great time interacting with many of you there. Several presenters and ELAP staff are there answering questions and chatting with participants. It adds a little something to the virtual conference experience. There's a link to join Slack on the conference webpage, and we also have it available through a link in the chat box here. Today's focus is a bit of a send-off. We'll start with a message from our own Robert Brownwood, followed by a mega presentation by A2LA Workplace Training's Michelle Wade. This presentation will be the grand finale for the many T&I documentation workshops that have been held over the past year. And finally, we will cap off the conference with some words from ELAP's program manager, Christine Sotelo. Before I get sappy about the conference ending, let's get to head to the great day we have. We have today's the Water Board's resident sailor here to help us get the day started off on the right sail. As the Assistant Deputy Director with the Program Management Branch within the Division of Drinking Water, Robert Brownwood has many stories to share of what he has seen and learned in the over 30 years of experience he has in the water industry. During that time, he has worked in every district from San Diego to Redding. He also spent 10 years managing the City of Tulsa water system, moving from regulator to regulatee. And as you're about to find out, he is known around here for his ability to find the perfect tale to illustrate his points. Please welcome Bob.
Thank you, Jennifer, and welcome everybody. As Jennifer said, I'm Robert Brownwood, and just wondering, if you're wondering, which I am, what sailing has to do with lab practices. Absolutely nothing. Unless, of course, you're sailing around the world and you happen to find microplastics and start sampling for microplastics and plastics out in the ocean, which I hear happened in the first session. So, but I do think there's some analogies and some comparisons between the two. And actually, you use the term Slack, Jennifer, for I guess it's a new web-based program or something where people can go to chat. Well, between high and low tides and low and high tides, there's what's called a slack. So even in sailing, there is a slack term that you need to know about every time you get ready to plot your course. And so just talking about plotting your course, making sure that you know where you're going and how to get there. Most often when people sail on the San Francisco Bay and they're new, they want to sail under the Golden Gate Bridge, which is right there in the very middle of the chart on the bottom right of the screen. And doesn't the chain of custody do the same thing? It tells the lab what the customer wants and how to decide the information the lab's going to use to give the customer what they want. But even before we launch, get on the boat and go for a sail, you want to plan your voyage and make sure the vessel's sound and ready to sail. And depending on the trip, you want to make sure you have adequate fuel. Even though you're sailing, you still have a motor, and you need that motor for many reasons: food, water, gear, equipment. And again, similarly, isn't that what the quality assurance manual is about? To ensure that you achieve your desired result precisely, accurately, and safely. As you can see, not being aware of your surroundings and not plotting your course accurately, you can run aground. And if you don't know your tides, when they're up and when they're down and what's in the water, you can end up on the rocks, or like these other boats on the left, you can be stranded at low tide. And so even that happens, right? Accidents happen, and knowing the tide and when it's going to come in, you just know, okay, we're going to sit here for about 4 hours and we have lunch and wait till the tide comes in and it carries us off. Next slide, please. So I was watching a PBS show the other day, and it was about these Teriobata, or Teriokai, and it's these Japanese fishermen's flags, and it's flown by boats to signify their catch. And the greater the catch, the more flags they have, and just to let people know when they're coming back, hey, we had a great catch, we got a lot of fish coming in. And these are hand painted flags on fabric, and incredibly intricate detail on them. And I was just watching this show thinking, man, is that not quality expectations, which we want? We want to know the quality of work that we're going to get from a lab. We, as regulators, we want to know that value, and we want to trust it. Katie Angeron earlier from New Jersey was talking about that, about dependability of the data, just knowing that you can rely on it, and quality of the data. And these flags is incredible. It's a show worth watching. And there's a painter in his 60s who did this just to make sure the art and tradition of this Terabata kept going, and wanted to pass that on to the generations to come. And so quality expectations, just a high quality that we expect from the labs. And I use this example a lot. It's when I was working here in the San Francisco district and inspecting a water system that had arsenic. And they had 5 results. And as you may be aware, arsenic, if you have an exceedance, you need to take quarterly samples, and we average the quarter to determine if you're over the MCL. Well, they happened to take 5 samples in this particular year, 2 in one quarter and then 1 each in the next 3 quarters. And when I averaged the 5 results together, all 5, and averaged those, the MCL, or the result, came out 10.5 parts per billion. When I averaged the 2 in one quarter and then averaged those to the other 3 quarters, the result was 10.4 parts per billion. And you may or may not be aware, but that the standard for arsenic is 10, and 10.4 rounds down to 10, and 10.5 rounds up. So that single, even how you average the result could be the difference between in compliance or out of compliance, requiring treatment or not requiring treatment. And I realize that you're probably thinking, you're kidding, right? 10.4, 10.5, it's a result. It is a result, but we select those numbers intentionally when we set our MCLs, based on this decimal point. So how many molecules is it between 10.4 and 10.5? I don't know. I mean, that's what we rely on the lab data to tell us, and the accuracy of that data, and to know that, okay, this result is we're going to trust in it, we're going to rely on it, and we're going to enforce it if it's over the MCL. And if we need to change our expectations as regulators because the lab results of what they provide, I mean, that's what we have LTAC, and that's part of ELAP's expansion to have an LTAC, an expert review panel that could provide input into us. And currently, from what I understand, what I've studied, most MDLs provide 99% confidence that the constituent exists plus or minus 50%. And that's kind of crazy to me when you think about 10.4 and 10.5. And would it be better if we had a 90% confidence plus or minus 10%? So those are questions we banter around, and we're not the lab professionals, you are. And so, no, getting results and high quality results, that's what we expect from the lab. And if those results or our expectations or understanding of those results need to change, by all means, let us know. Next slide, please. Oh, that's such a pretty slide. So once you're got your course plotted and you're ready to go and you know what to expect, there's always fine tuning to be involved. So I just found this in one of my lab books, and it says the Winchester quart should be cleaned with strong sulfuric acid and then be washed with ordinarily good water until the washings are no longer acid. And that's from Water Analysis, a Practical Treatise on the Examination of Potable Water, 2nd edition, Trubner and Company, London, 1870. So we have come a long way since 1870, and it's because, one, technology has improved, obviously, but the need for technology to improve has come a long way also. And we continuously fine tune the process. You do at the labs, whether it's painting like the previous slide, or sailing, or seeking spiritual enlightenment, or playing a musical instrument, or practicing martial arts, or managing staff resources, or running a lab. There's a state of quality of improvements or techniques to achieve as close to perfection as we strive to be. So we're always striving to do our best. And the pictures of these radios, I don't know how many of you remember the old time radios. It had two tuners. One, you had this coarse tuner that would zip along the dial, and then once you got near the radio station, you had this fine tuner that would dial you right into the station you were looking for. And this fine tuning concept is something I strive for and to incorporate into my daily life. And in sailing, a sailing term, we call that trimming the sails. And you're always the winds are changing, the currents changing, the conditions are always changing. So you're always having to tune the sails and to trim your sails and to set your course and change your course along the way at times. But it's this constant fine tuning to get the most out of your sail. Next slide, please. And then there's maintaining awareness. It's just being aware. And Erica Chung was talking about what she found, and she became aware of that, and she made it known to her supervisor. So it was awareness and communication. Unfortunately, they chose to not respond and not to make course corrections. And you heard that presentation yesterday. But it's just being aware of the situation and communicating and responding. We were out sailing one time, and the crew was kind of sluggish the day. And I don't try. I'm not a Captain Bligh. I try and allow the crew to learn and grow as we sail. And they're just kind of sluggish. They weren't responding when the helms person says prepare to tack, which means I'm going to turn. The crew gets ready because they're going to change sails, and they say ready to tack, and then the helms person says helms a lee, and they turn, and then everybody does their job. And this particular time we're sailing near Marin, between Angel Island and Marin, and she was saying prepare to tack, and nobody was responding. Prepare to tack, nobody responded. So are you guys ready? And they, oh yeah, ready to tack. And she says tack, and too late, we were already in the mud. So we had to wait there about 45 minutes as the tide came in and picked us up off the mud. But it's just, again, it's being aware always of the situation, and if you see something, make a correction if you need to, and communicate. And next slide, please. Then it's getting to your destination safely. In a sail, that's extremely important. And in and out of dock and getting to where you want to go. it's, you want to be able to enjoy. You want to be, when you're sailing, you want to get to harbor and port and go in there and enjoy a nice restaurant or wherever you are. No different than labs. I mean, customer gives you a sample, you run the analysis, and they want to know that they can, as again, going back to Katie's presentation, the word safe, such a nebulous, ambiguous term, but it's in our statutes that we are to provide water that is safe, wholesome, and potable at all times. And how do we know the water's, in quotes, safe? Part of it is it meets drinking water standards, and those standards rely heavily on the lab results and the value and the reliability of those results. And you want to enjoy that success. So we are wrapping up ELAP Con, and hopefully you've had an enjoyable sail and you've learned a lot of things, seen a lot of new information that you can incorporate into your lab practices to improve and or to just have better sense of security that, yeah, we're doing a darn good job, and we can rely on, people can rely on these results. So I thank you and hope you enjoy the rest of this session.
Thank you so much, Bob, for the great stories and encouraging message. We are so glad we were able to hear from you today. Our next speaker has spent a lot of time with many of you over the past year. As part of the T&I documentation workshops presented by A2LA's workplace training, Michelle Wade has had the opportunity to interact with you and answer many of your questions. Michelle has over 12 years of experience working as an assessor and drinking water certification officer. She is currently the chair of the T&I Chemistry Expert Committee and is a former member of the Quality Systems Expert Committee. We asked Michelle to look back over her time running the workshops and provide some additional thoughts on areas that had the most questions. We invite you to grab some note paper and get ready to dive right in. And don't forget to add your questions to the Q&A chat box as you think of them. Michelle's going to take a break and answer some questions in the middle of her presentation, so be sure to have them ready. And with that, I will hand things over to you, Michelle.
Thank you, Jennifer, and good morning, everyone. I am excited to join you for this last voyage with the T&I documentation workshop. It has been a long time coming, and we've worked with a lot of you, and it's been a very enjoyable experience. I will say that I am kind of happy to move on from this training and to do new things, but in the meantime, we've got you started. We've got this final voyage. We're going to talk about some things, and hopefully you'll continue to learn from me and A2LA Workplace Training as we move forward. Next slide, please. And we just asked, I know that the conference has been recorded and it'll be pushed onto the YouTube channel, which is perfectly acceptable and fine. But A2LA Workplace Training does ask that, any other recordings we kind of keep to ourselves and not put out there. But we'll move on with the next slide. Give you an opportunity to tell you a little bit about me. So from many of you know, my name is Michelle Wade. I work with A2LA Workplace Training. I am known nationally as Michelle from Kansas, and that started back as my time with the state of Kansas. I worked for the Kansas Department of Health and Environment for about 5 years. My title was Laboratory Improvement Specialist. And when you go to a T&I conference, you have to do the full thing. So my name is Michelle Wade. I work with KDHE, and I'm a Laboratory Improvement Specialist. And it was so long, and I just shortened it finally, and I was just Michelle from Kansas, and it stuck. So, Michelle from Kansas, work with A2LA Workplace Training. I am an assessor and a consultant. I do third-party assessments on behalf of A2LA, and we work in a number of states, including California. We also work with Florida and New Hampshire and Louisiana and Minnesota, and I don't know where else, but we sure go a lot of places. So our specialties are, of course, with T&I. So we do a lot of T&I assessments. We also do ISO 17025. So that's a little bit about me. We're going to move forward here. So what to expect from this presentation. So what we're going to do today is we're going to discuss an overview of the workplace training seminars, what we've done, where we've been, and then what we've found with that. So major findings that we've had from California assessments. We have a number of assessors that have done work in California, whether it's been for just California ELAP assessments. Some of them have been TNI -2 assessments. There's a handful of DODs, some others that we've done, but we've taken all of those findings that we've had from California in the last few years, and we kind of pulled them out and took a look at them and digested them to come back to you and say, hey, this is what we think you need to look at today, so we could do that final voyage and focus on those things that we're still struggling with a little bit. We're going to explain those key management concepts from the TNI standard. I'm going to cover that all again just briefly, and then we're going to review sections of previous trainings from the California and then highlight a few new things that we've been struggling with that we've seen through our investigation of our findings. So just an overview of everything. You'll see both myself, there's more than that. So Chris Gunning on the top there, and then Nick Slauson as well. Some of you probably heard from them instead of me. We kind of split up that training so that we could all do other things, at least 1 week a month that we dedicated to the California training. So just so you're aware, HLA workplace training was contracted by the California State Water Resources Control Board, and I still think that is a huge need, guys. We need to make that shorter. Just put that in your notes, make it shorter, Jennifer. To produce training addressing specific policy and procedure requirements that were felt to be new concepts to California laboratories within the TNI standard. We provided 8-hour courses over 2 days, once or twice a month. There was a lot of them. In fact, there was 20 of them over 14 months to approximately 600 registrants within the state of California. The idea was that we'd have one person per lab that would take the training and share that knowledge, and then there'll be recordings available on the website, the California ELAP website, at some point in the near future. I'm guessing those have been forwarded on. So it was an introduction to fundamentals. Ooh, not quite there yet. To quality concepts and quality management systems. There's a description of those benefits of implementing those quality concepts and management systems in your laboratory, an overview of the 2016 TNI standard, and we provided lessons on key applications of the standard in your laboratory. We also looked at ways to simplify that language, and we're going to continue with that today. So I'll let you move forward now. So I love this picture. I was looking for something to throw on there because my boss hates wordy slides. So there's the truth, and also I throw pictures in to make him happy. But I will say this is my opportunity to tell you about my experience with California and how they have worked with you as the laboratory. So through my 15-ish plus minus more plus years working in the industry, I watched both Minnesota and Oklahoma come on board with TNI and full-blown TNI states as well. So, and I will tell you from all of the interactions that I had with the state when it happened, through all the interactions that I saw with the laboratories, from the times that I've been into those laboratories and worked with them and talked to them at conferences, I will tell you a little bit about California and that no other state has offered the amount of training and support that California has to their laboratories. Previous training sessions, as well as access to the TNI standard and other documents, was more than what any other state had provided at all to their laboratories. But when looking at the training and participant guide and the templates and HLA workplace training provided to laboratories free of charge from California working with us to do that, it is absolutely astounding the amount of information that has been provided to you through those resources. And I will say that having sitting in a consultant seat and as an assessor, there are a lot of labs out there that are currently TNI laboratories that would love to have access to those documents. So California has really, put themselves out there to give you guys that opportunity to move forward the standard and to succeed in that process. Go ahead and have you move forward now. So this probably looks really familiar to any of you that sat through our training. We did that roadmap of training. We were asked to stick with that roadmap. That's California's thing, and we actually love it. We think it's a lot of fun. So here's our roadmap of training. Things that we looked at was that introduction to the quality management system, the benefits of implementing it in your laboratory. We looked at parent organizations and that quality management system development and how you can intertwine those a little bit more. An overview of the standard itself, what it looks like, what are the pieces, and then understanding the standard. That was always the wording. That was always a good one to have for you guys because some of the words are a little bit more challenging, especially when we look at the ISO aspect of things. And then those applications and clauses, which was absolutely the meat and potatoes of our training that we provided to you guys, was going through all of those clauses within the standard and providing you with direction on those. If you go ahead and move forward there. So the key sections and clauses, this was our meat and potatoes. We split that out into 3 sections when we did the training. We looked at the focus sections. Generally, we finished that in the first day. Generally, not always. It depended on the training session. We always tried to answer your questions. And then we moved through important sections and noteworthy sections. And those were all things that we felt in decreasing value were benefit to you. So we started at the front, worked our way through. 95% of the time we made it all the way through our presentation, but not always. So that was just a reminder of what we covered previously. If you go ahead and next slide. I also wanted to remind you about the tools that we provided to you guys. So this one was, like I said, this was absolutely amazing to get this. I would have loved to have had it when I was, new in the laboratory. So you got a copy of the slide deck from the training, which is, just general knowledge. Keep your notes on it. That participant guide, which included an explanation of the what's and whys of the TNI standard, as well as conforming and non-conforming examples. And those were from examples from laboratories across the spectrum, commercial, municipal laboratories, large laboratories, small laboratories, and from a multitude of states. So they weren't just from one location. We tried to give you a lot of different examples. And then we also provided those templates as well. We also gave you that wonderful job aid that talked about everything that needed a record versus what needed to have a procedure written for it. So that was all available to you, as well as that history of TNI, that because sometimes if we know where things came from, it's a little bit easier to understand where we're going. Next slide. Well, let's, enough of looking back at what we have done. Let's move forward with what we are going to do. So I told you in the beginning, A2LA looked at the deficiencies that they had on file. So when considering what we would discuss in the final training session, we decided to utilize the resources we had with our partners at A2LA, and they graciously pulled the deficiencies from all of the assessments and pre-assessments that had been done in California by our knowledgeable assessors so that we could see what trends we had. We looked at a total of 745 deficiencies, folks, that came from laboratories in the last 2 years. 54% were TNI citations, 46% fell into the other category, which is going to be regulatory, California or federal, method, SOB, and then the occasional DOD gray box citations. And if you don't know what I mean when I say that, count yourself lucky and just move forward. Next slide. So I set aside all the others and we just focused on that TNI citations because that's what we're really here to talk about. So of those TNI citations, 322 or 80% of those fell into quality management systems, V1, M2, and that included both sections 4 and 5 for management and technical. We had up next was the chemistry module, V1, M4, with 33 or 8%. V1 M5 at 30, also 8%, you got to do some rounding there, was the microbiology module. And then from the PT module, there were 15 or 4% of those. So that was kind of how the breakout happened when we looked at the citations that came from A2LA. So we'll move forward. The next slide. The top citations for V1 M4, chemistry and microbiology include, because I didn't want to just ignore them because they are very important. They just weren't really covered by our training that we did with workplace training. So both module 4 and module 5 for demonstrations of capability were exceedingly important. Please remember that there are 4 reps of a standard in both chemistry and microbiology. For quantitative microbiology, and it also requires replicates of both known positive for precision and accuracy purposes. So more information can be found in section 1.6 of both modules 4 and 5, but I wanted to make sure that we talked about demonstrations of capability and things that you want to look forward to in your laboratory and maybe research a little bit more. If we looked at just the chemistry module, V1 M4, instrument calibrations, there is a lot to digest in 171, which is calibrations in V1 M4, a lot. And I will tell you that with the 2016 standard being relatively new, a lot of the TNI laboratories that are already in place are also struggling with this. So please don't feel that you're out of line or we're not doing things right. And oh my gosh, nope. It was all new requirements, a lot of new requirements, and a lot of people are struggling with it. So not just you, but a lot of people. But we want to make sure we pointed that out as a section that you guys could really focus in on yourselves. For microbiology, where we saw the biggest number of findings within California was with the sterility checks. And I just wanted to give you a reminder that 1731A requires that all materials and supplies, all of them, that are needed to process the sample and are required to be sterile, that's a lot of things, folks, prior to use, whether it's sterilized by the laboratory or purchased sterile, must be checked by the laboratory once per purchased or prepared lot using non-selective growth media as appropriate. So in many cases, that's going to be tryptic soy broth. So sometimes we have to be a little creative when we're doing that. How are we handling Petri dishes? What are we going to do with pipettes? But if it's required to be sterile, you have to do that sterility check. So just a reminder, things to look at and consider as you move forward with 2016 TNI in your laboratories. Next slide. So V1, M2, that was what we covered when we did all of our training, and that's where we're going to focus again today. So we looked at all of those deficiencies that happened there, that 80% of total came out of this section. So the number one section we had was 4.2 for management. There were 61 deficiencies that were found there. I will say that when we looked at the stats and we looked at all of this one took us a little off guard. But then we remembered that quality systems are a relatively new concept to the labs in California, particularly with the level of detail that TNI requires. So once we stepped back and looked at it a little bit more, we're like, oh, that makes sense. And I will say that in our training that we provided previously, we never really pulled 4.2 management out as its own unit. We incorporated many of those concepts within all of our additional training. So today, I'm going to focus on 4.2 as for part of my training, and we're just going to look at that management structure. We're also going to look at 4.13 again with control of records and section 5.5, the calibration requirements. And this would be for more of your support equipment requirements. So again, areas that we saw a number of deficiencies in within California and hit our top 3. So we'll go ahead and have you move forward, and we will look at the management portion. So again, we dispersed 4.2 throughout the training previously, and so we really wanted to focus in on that today when we did this training. So section 4.2.1, and just so you know, guys, I'm going to walk you through the standard. We're going to talk about things. We'll provide some information and feedback. There'll be a Q&A portion, right? So you guys are taking note of questions, and Jennifer will read those back to me, and we'll work through it. So I hope as I move forward, if I get to the point, Jennifer, that you're like, oh, Michelle, you need Q&A time, let me know, stop me, make me shut up, and I will certainly do that. But we want to make sure we have time to answer all of your questions. So 4.2.1, it deals with the appropriateness of things. The management system must be appropriate to the laboratory manual or to the laboratory itself. That includes your quality manual and your SOPs. It must be understood by, available to, and implemented by appropriate personnel. And that's a whole lot of words to say that you have to have it. They need to read it, and there needs to be a record that they have not only read it, but agreed to implement that themselves. So we used to call this back in the day, which doesn't mean a whole lot to you guys, but back in the day, we referred to it as read and understood documentation. And that was kind of the easiest way to go about this, was that we had, a document that everybody signed. I've read this version of the quality manual and the SOPs listed below, and I agree to follow them. So read and understood, 4.2.1, make sure everything's appropriate. And we'll move forward with the next slide here. So 4.2.2 requires a quality policy, and this is going to be part of your quality manual. The quality policy itself, I know that there was information in the document that we provided to you through the training process in regards to the quality policy, but there's a number of things that must be included with that quality policy. And it has a lot of detail in the standard as to what that needs to be contained, or what needs to be contained there. So we need to have a management commitment to the quality of testing in the laboratory. A management statement of standard of service. This is really kind of like a mission statement or a value statement, those sorts of fancy management words that we put in some place, yes. Purpose of the management system related to quality, the familiarity with those policies and procedures. So that's where we talk about all personnel needing to be familiar with them, and especially those things that apply to their work. And then that commitment to comply to this standard, and this standard being the 2016 TNI standard, and then continuous improvement as well. So I know we worked at defining continuous improvement through our previous training, and really it's a concept that we that happens through all the different things that we do: internal audits, management reviews, complaint reviews, feedback, all those sorts of things kind of go into that continuous improvement as we move forward with preventative and corrective actions. Next slide. And looking at the additional ISO requirements that fall into 423 through 427, there needs to be evidence of continuous improvement and implementation of the management system. Don't freak out about the evidence, folks. You're creating that evidence through the rest of your processes and procedures. You have a record of your management review. You have a record of your internal audit. You have a record of corrective and preventative actions. So as long as they're in place and you have those records, you have that evidence. The quality manual must have supporting procedures or make reference to them. And that's when we talk about procedures here, usually we as laboratories think of SOPs, and SOPs are very clearly defined. We'll talk about it later, and all the many components that are required to be in a technical SOP. When we're talking about this sort of a procedure, it doesn't necessarily have to be a formal SOP, but it's more administrative in function. And so we wouldn't necessarily expect to see all 15 of those requirements that TNI has. A lot of them are going to be not applicable. You know, we don't really necessarily have interferences. We might. I mean, I guess you could write interferences into your procedure for internal audits. That could be fun. But generally speaking, these supporting procedures are really the how do we do this in our laboratory? And it can actually be included as part of your quality manual without having to have a separate document. We need to look at the roles and responsibilities of management. So we need to describe those roles and responsibilities. And at a minimum, this is going to include your technical manager or your quality manager, however you name them. They're kind of generic titles that we have in the standard. A lot of people get hung up on them because of the management title that goes with the standard on that. That's not what was intended at all. We're just trying to focus on those higher level people within your laboratory, the ones making those decisions. And so you may call them a number of things. And TNI is moving forward with the newest revision of the standard and looking at ways to get rid of that management title in the standard so that it's a little bit easier for everybody to handle and deal with within their, especially the municipal laboratories. We also need to ensure the integrity of the management system when changes are made. So through this process, we want to make sure that if there is a change in technical directors or quality managers, that there's enough documentation in place that the new person coming in could pick it up and move forward with the management system without a whole big series of issues that would stem from that. It's very similar to having an SOP that your laboratory staff can follow. So if somebody with, with general knowledge of how, let's say, an IC works, could come in from working in a different laboratory and follow your procedure to run the IC in your laboratory. So it's the same concept, just with management systems and a little bit more, not technical. Next slide. It also requires us to look at data integrity systems. So data integrity is defined by TNI as the condition that exists when data is sound, correct, complete, and accurately reflects the activities and requirements of the standard. We as humans, again, know right from wrong, but by documenting this and having staff sign off on it, you're really creating a cover your rear situation where if any analyst chooses to, quote unquote, go rogue, you as management have a document to point to that says we told them what they could and couldn't do and they signed off on it. Most of us don't look at data integrity that way, but that's really what the requirements are for that and why we require that sign off on the attendance. There are 4 required elements within the data integrity system. Includes data integrity training, signed data integrity documentation for all laboratory employees, periodic in-depth data monitoring, and data integrity procedure documentation. The data integrity procedure shall be signed and dated by top management and reviewed on an annual basis. This is generally covered if you have that in your quality manual, and your quality manual is signed off on and reviewed on an annual basis. The requirements for what must be covered by the training reside in section 527. The training documentation needs to include a signed attendance record for the training, as well as a signed agreement from the staff that they have participated and understood their obligations. This really could be one and the same if you have your attendance sheet worded properly. And a lot of laboratories choose to have their staff sign off on the policy itself. And a lot of times we see that as an appendix to the quality manual. When we look at in-depth monitoring, that can occur alongside your internal audit folks. So we're not necessarily asking for a whole different procedure here. Look at ways to incorporate what you already have to do and get as much out of it as you can. So with in-depth monitoring, we want to make sure that you dig down deep into your data, and that's what we would expect during an internal audit. You want to make sure that we apply that cradle to grave theory of samples and standards from the time it arrives to the laboratory until it's disposed of after analytical testing. And this isn't just a cursory review of data for quality. You need to consider traceability and the timeframes as well. Documentation of your procedure is commonly done as an appendix to the quality manual, as I said, but doing so, it's generally signed by top management and this when they sign off on the quality manual itself. So, next slide. The section also, 4281, also requires you to have a procedure for confidential reporting of data integrity issues. So there's no one correct way to ensure confidential reporting of data integrity issues. Likely you already have something in place within your laboratory. And some examples include, but are not limited to, having an open door policy with management so that you can come in at any time and voice your concerns that you may have. Sometimes we have a reporting process to HR so that you're going outside of the laboratory, but we've got a place where we can say, hey, I think there's an issue here. Whistleblower protections are in place corporate-wide and even within municipalities. I know that I just did my data integrity training for the state of California, and it talked about whistleblower protections too. And then external reporting. In a few instances, some of our larger commercial laboratories actually have like an 800 line where their lab staff can call and report any sort of data integrity issues. Leave it as more of a that completely confidential process. Next slide. Wanted to briefly touch on 527, just as a reminder of what's there, because it's not part of this section, but it very much flows into it. We need to understand that staff need to know what the problems are with, when it comes to data integrity. So that includes falsification of data, what could be considered a problem, like obliterations and records, what we expect from them. And every city and company that I've ever been aware of has some sorts of an ethics agreement that you sign off on as a general employee, and what the consequences are for not doing the right thing, which may include up to termination or criminal prosecution, which we hope is never the case. But once in a blue moon, things get really, really bad out there. They also need to understand that everyone makes mistakes and that reporting a mistake when it is found is the best way to prevent there being any unnecessary consequences. Next slide. Quality manager or quality manual. The quality manager is responsible for maintaining the currency of the quality manual. That's 4282. 4282. And in a nutshell, it says, just that. You have to have that quality manual up to date, and the quality manager, or however named, folks, it doesn't have to be quality manager. Maybe it's quality assurance officer, maybe it's senior chemist, maybe it's supervisor in training. You call him Bob, I don't care. The quality manager has to keep the quality manual up to date. So 4282 and 4284 cover what must be contained in the quality manual, folks. And I'm not going to lie, there's a ton of things. And a lot of these things we incorporated in our previous training, but we're going to talk about each one of them individually now. So 4283, that's going to be your structure of the quality manual. It's pretty straightforward here. We need to have a title. That can be pretty simple. We can call it, City of XYZ Quality Manual. Pretty straightforward, but it does need to have a title. It needs to include the name and address of the facility, and the name and address, if different, of the responsible parties. So when we look at that quality manual, we want to know where to find you and who we need to contact. We also need to have an ID of whether it's covered by the quality manual effective. That's a huge typo there. So the idea of we want to have an effective date and a revision information for the quality manual itself, and then an ID of approved signatories as well. Continuing on with 4283, we need to have a signed and dated concurrence of all responsible parties when they sign off on the quality manual. That generally covers that. It needs to include the objectives of your quality system. That's covered by your quality policy. It needs to contain or reference policies and procedures for the laboratory, and 4284 covers in great detail all of those that need to be included. Has to have that quality policy statement that we previously talked about and all the things that need to be incorporated in it. And it also needs to have a table of contents, references, glossaries, appendices, those typical document things that we expect to see. So the quality manual contents, folks, we kind of split these out into different things. And mostly that happened because my boss thought my slides were really wordy. So we did split them out into, I'm truthful about things. He doesn't like wordy slides. You need graphics. Okay. They're hard to follow. I got you. Okay. So procedures, all the many procedures that must be covered by your quality manual. Again, folks, this is things that are written into your quality manual to tell you how you're going to go about these things. This could also reference an outside procedure. So if you do have an SOP for internal audits, a separate SOP for management reviews or corrective actions, you can simply reference that in your quality manual and not have to rewrite everything. So, you don't have to reinvent the wheel every time. But these are all of the different procedures that we do need to make sure we have included in your quality manual. That's going to include maintenance, calibration, and verification procedures used by the laboratory in conducting tests. This is going to be more of a generic statement, and oftentimes we're going to reference the SOPs for additional information. We need to have procedures for reporting the analytical results. If you are a commercial laboratory, there's a very defined form in which things have to be not necessarily a form itself, but all of the items that have to be included in a report. If you are a municipal laboratory or it's internal, of course, there are caveats in there for doing things differently. All of that information still needs to be available, that we could locate it in the laboratory, but it doesn't necessarily have to be in a formal report if you're using the results internally. We need to have procedures to ensure that all records required under the standard are retained, as well as procedures for control and maintenance of documentation through a document control system that ensures that all standard operating procedures, manuals, or documents clearly indicate the time period during which the procedure or document was in force. So that's a whole lot of information right there. But it's really saying that we have to have those records and we have to keep them around. And that's going to also include your SOPs, your quality manuals, all those other things. They are documents, but they are also considered to be records. It's what we use to, we follow this SOP to complete our test. So it's a record as well as to how the test was completed. Traceability of measurements. So you have to have procedures for achieving that traceability of measurements. It's going to be using NIST references. It's going to be using, standards, primary standards in your laboratory that can be traced back to the manufacturer, having the certificates of analysis on file. We need to have procedures for ensuring that new work gets reviewed. This is, of course, a big thing for commercial laboratories as you gain new clients, but in our municipal laboratories as well, if you are asked to do additional testing in your laboratory, you need to have a review process in place. It doesn't have to be extremely detailed. You don't have to have a separate form. You just need to kind of tell us how you're going to go about it. Like if we're requested to do additional work, we're going to make sure that we have the materials and the staff to provide the work and that we are properly accredited for what needs to be accredited. It can be short, blunt, and sweet, folks. It doesn't have to be overly complicated, but you do need to have a procedure for how new work is going to be reviewed. You have procedures for handling samples. I will tell you that there is a whole detailed section on handling samples in Section 5 of 4.2, or Section 5 of the Volume 1, Module 2. And yeah, have fun with that. There's a whole lot that goes in there. But generally speaking, what we found is that you guys are already doing those things. It's just a matter of kind of formalizing things a bit. We have procedures to be followed for feedback and corrective action whenever testing discrepancies are detected or departures from documented policies and procedures occur. That's going to be, so you have to have that procedure for getting feedback from your client. And if you sat through the training with me, we had a big discussion about who your client is. So remember, whoever utilizes your data is your client. If that's, the people that you send your formal reports to as a commercial laboratory, great. If it's the plant superintendent who reviews that results to kind of determine what they're doing in the plant, great. But you do have a client, no matter who you are. And then, of course, those records for corrective actions and preventative actions as well. You need to have procedures for dealing with complaints. A lot of times people say we don't have complaints, and we talked about complaints in detail during our training as well. And remembering that complaints can be inquiries as well. And us folks from the Midwest, we don't, unless they're, our first name is Karen, we're generally pretty polite when it comes to complaints. Hey, I don't think this is quite right. Would you mind looking at it? Still a complaint, even though I'm not necessarily angry. Something that you need to look into, but we need to know how we're going to handle that and how we're going to document those things. And then procedures for protecting confidentiality, including national security concerns, which probably isn't a big thing for most of you, but could be, especially if you're doing DoD contract work. And then proprietary information as well. And then finally, I guess not finally, actually. Procedures for audits and data review. I'm ready to move forward. Audits and data review, this is internal audits. It's going to be external audits, all of those sorts of assessments that happen, and then reviewing your data as well. So we want to make sure that there's a process and procedure in place for how we're going to review data through the laboratory, whether that's through a LIMS system process, or I'm going to review my neighbor's work and I'm going to date and initial the bottom of the form. Both perfectly acceptable, but we need to know how we're going to do that. And then electronic signatures, and this is one that creeps up on people because we don't necessarily think about it, whether that's we're shoving an actual PDF where you like signature where you have to like type in everything into Adobe and it's all fancy and formal. You get the little box at the bottom that says, you know, electronically signed by. It's all spiffy. It could be something also like and a lot of times for me and what I do, it's actually a JPEG of my signature. And so we actually insert that into the document, print to PDF, and then remove it as well. So it could be that way. It could also be, maybe it's a typed, you know, if I type it in this font onto the form, it's at that point electronic signature. But if you're going to use electronic signatures, you have to have a procedure for it. Next slide, policies. So policies for permitting departures from documented procedures or from standard specifications. So you do have to have a policy for how we're going to handle any sort of departures that happen, whether that's SOPs, whether it's our internal audit. We need to know how we're going to document those things, and then a policy also for using those electronic signatures, as I discussed. That one was a little bit more straightforward. Remember, a policy, guys, and you don't need to go back, a policy is telling you what you're going to do. The procedure tells you how to do it. So the other, this was kind of fun when it's like, what do we do with everything else? We put it into an other category. Other includes major equipment and reference measurement standards used, as well as the facilities and services used by the laboratory in conducting tests. We need to have verification practices, which may include interlaboratory comparisons, PT studies, use of reference materials, internal QC schemes. When you get into some of the more exotic type things, it's going to be like round robins with your peers and other laboratories. There can be a lot that goes into that, but it just gets covered in your quality manual and we move forward. The organization and management structure of the laboratory, its place in any parent organization, and the relevant organizational charts need to be included. And there's usually a whole section on your organization under 4.2. We need to have job descriptions of key staff and reference the job descriptions of other laboratory staff. So this is going to include your quality manager, technical director, however named, folks. Again, don't get hung up on titles there. It's going to include your lab staff as well. It can be your full, if you have like a full job description, say from the company HR or from municipality, you can include those in the document. You can put them as an appendix. You can reference them. A lot of times, if you're going to do that, you kind of want to pull in those things that are specific to the laboratory, because that might include other things as well. So it's kind of up to you. There's flexibility in how you go about that along with many of the things in the standard. So we do have to reference or include job descriptions, and then a list of the methods under which the laboratory performs its accredited testing. So we need to know what in that quality manual, you need to find what it is you're actually accredited to test for versus things that you may do for process control or otherwise, so that we can determine from reading your quality manual whether it's something we expect to fall under this quality system, if it's something that's kind of handled over on the side separate from. I highly recommend, folks, that if you've got a quality system in your laboratory, which all of you do now or are working towards that, that you go ahead and just include everything in that, whether it's an accredited method or not. And then there's none of that, ooh, do I do it this way or do I do it that way? You just do everything the same way, and it makes life a lot simpler for everybody involved. Next slide. Let's talk about 4285 and SOPs. And this place, we're actually talking more of those method SOPs. So this is going to be your more detailed ones. They need to accurately reflect all operations and methods. Those documents must be sufficiently detailed to allow for someone similarly qualified to reproduce those procedures. And SOPs must be readily accessible to all personnel. I will say in one instance, I actually had a laboratory that the SOPs were housed in the quality manager's office. And oftentimes the quality manager left early and the door was locked and they couldn't access their SOPs. And the staff complained about it to me, and I'm like, oh, now I have to do something about it. So make sure your staff can access their SOPs and they know how to do it as well. So if it's housed on a server, that all of your staff know how to click in and get to their SOPs that they need. Next slide. Your SOPs, just like your quality manual, must have an effective date, be signed, and have a revision number. It is quite frequent that we see those SOPs don't have a signature on them. They're going to be approved through the same process essentially your quality manual is. So we do expect to see some form of signature on them, whether that's electronic or a physical signature. And you must have an SOP for each analyte and method on your scope. This includes calculated results such as hardness or unionized ammonia. It's going to include those very simple things that we don't necessarily think about. Temperature, pH. If you have them on your scope, folks, you have to have an SOP that covers them. For those calculated results, because I know I can't see you, but I know a number of you are like all up in arms, like, oh my God, why do I have to have a separate SOP for this? You can include it. So if it's metals, and you've got your calcium and your magnesium results and you're going to add them together and it's really just that simple, include it in your metals SOP. It doesn't have to be a separate document, but they do have to be included somewhere in an SOP. Next slide. In theory, I will tell you that the laboratory can use manuals or methods from manufacturers. You could use your EPA methods, your standard methods, all of those sorts of things. There is a caveat in the standard that allows for that, but you still must meet all of the requirements that fall under F that we're going to go through now. And I will tell you that most of those documents don't include all of these items, and it becomes a very messy result if you have like a standard method and then your SOP and you combine the two and you have to reference back and forth. It is a very confusing process for everybody involved, whether it's your staff, your assessor, all of those sorts of things. We want to make sure that you can do it that way. I just don't highly recommend it. When we look at those SOPs that we have, we do need to make sure that we identify the method. So that's going to be that's going to include like your revision information on that as well, folks, because remember, a revision in a method can make a huge difference in what's expected of you in regards to the requirements. So even something as simple as the samples have to be chilled on the auto sampler as opposed to not having to be chilled 524. When they made that revision, you have to follow the whole method. So having that revision information is very important. We need to include our matrices, the applicable matrices. The method may cover multiple matrices depending on where it came from, but we want to focus in on what we're using it in our laboratory for. So is it drinking water, non-potable water, solid hazardous waste, wherever you're using that, make sure you've got that matrix identified. We need to talk about our limits of detection and quantitation. Here's what I will tell you about that, because these numbers can fluctuate, is that sometimes, generally speaking anyway, we don't necessarily want to include the actual LOD in your SOP. Some of them are method defined, like BODs. That's pretty simple, straightforward. It's not going to shift on you. You do have to reference it in your SOPs, so I highly recommend that you reference back to the document where it's stored, the table where you've got that information. You can put it in there, but remember, anything that's in your SOP has to be followed, so if that number shifts and changes, you have to go back and change it in that SOP as well. We want to make sure we cover the scope and application, including analytes to be analyzed in the laboratory, and then a summary of the method as well. Most of that information, that scope and method summary, you can pull from whatever your reference method, EPA standard methods is. A lot of that information is right there and readily available for you. No need to reinvent the wheel unless you really want to. Next slide. Looking at additional things, we need to have those definitions. So a lot of definitions are already in our quality manual. They're included elsewhere, but if there's something very specific to that test, we want to make sure that those items are defined so that people know what you're talking about when they look at it. Interferences. What those are generally covered again in the reference method. It'll tell you what those interferences are. And you also want to talk about how that you handle them in your laboratory. Sometimes a method will have interferences that you're not going to see in your matrices. And that's perfectly acceptable to say as well, that the method references these interferences. However, our laboratory doesn't experience them because we only do drinking water. You're not going to, hopefully, not going to have like an oil residual issue or some of the other things that can commonly come up as interferences. You want to address safety even briefly within your method, so you can also reference any sort of safety documents that you have elsewhere in the laboratory. You also want to cover anything that's like unique to that particular method. Maybe most of your methods you only need a glove and your safety goggles and your lab coat, but maybe this one there's like you have to do this in a fume hood because it's it could kill you otherwise. Those sorts of things are important to put in your SOP so people know. Equipment and supplies. that's going to include all sorts of things. It can be pretty generic. A lot of the methods, again, especially the EPA ones, have that information available for you. And you want to make that unique to your laboratory and what you utilize. But sometimes I walk that line between assessor and consultant, and I will tell you not to get overly specific in that equipment and supplies, because if you reference a specific part number and you're using a different part number because that vendor didn't have it and you ordered it from somebody else, it can cause, I hate to say low-hanging fruit issues, but that's exactly what it is with your assessor. So again, individualize it to your laboratory, but don't get so specific that you write yourself into a corner. You want to look at reagents and standards, anything that's going to be utilized during that test, and those are going to be listed out. And then sample handling, so anything specific to that sample, be it holding times, pH preservations, sodium thiosulfate for microsamples, those sorts of things. You know, timing, we want to make sure that all gets covered in that sample handling portion. Next slide. We're going to talk about quality control and something specific to this method. So your quality manual is going to have some pretty generic quality control information in it. You know, we'll use blanks and control samples and blah, 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 but we want to be very specific in this to that method that we have the SOP for. So if we have to run additional QC for whatever reason, some methods require it. You know, some methods require your matrix spike be a matrix spike, have a matrix spike and a matrix spike dupe. Some methods you can have a matrix spike and a sample dupe. So we want to be specific within that method as to what quality control you're going to follow for this particular SOP. Calibration and standardization information, including what levels we're going to use to calibrate, how many we're going to use. I'm kind of slowing that down a little bit. Look at the volume 1 module 4, folks, and what is required of this. It's also going to include error calculations. So under the TNI standard, you have to do an error calculation for at least your low and your midpoint. Some methods require it for all of the points, but you want to make sure that's included in your SOP as well. The actual procedure for how to do things. I like to think of this as kind of the recipe so that I can follow this and that my results will be the same as everybody else's results, hopefully within reason. You know, sometimes things flop and it's okay, and you just move forward with your non-conforming work and life goes on. But generally speaking, this is how we follow. This is what we do. It should be unique to your laboratory. The generic procedure that's in your method likely is not going to cover this because you have different things. So keep that in mind. Your data analysis, how you're going to look at that data when it's all done. What are we going to look for? And those method performance criteria, you know, it's very similar to quality control, but it's going to be unique again to that method. Next slide. Pollution prevention. We require it as part of the SOPs, and I think that's actually a fallout from an EPA requirement for drinking water. So the pollution prevention does need to be included in there. You can certainly reference other documents that you already have in place in your laboratory. You do not have to rewrite the wheel. But if there is something specific to that particular test, like say you're doing CODs and you have mercury waste, you want to make sure that you address how you're going to handle that, like where you're going to put that waste. Data assessment, again, what are we looking for? Those quality control limits, how we're going to review it in the laboratory. Corrective actions is kind of a fun one, folks. So you're going to look specifically to that test, things that may happen on a regular basis and how you're going to handle them. So if you have a method blank failure, what are you going to do? If your LCS, you know, flops high, what are we going to do there? So those sorts of corrective actions, when they're put into your SOP that way, it gives you a very straightforward troubleshooting guide that you can start with. You know, it's a non-conformance at that point until you have trends. We talked about that in our training sessions as well, but those corrective actions, the basic ones, need to be included in your SOP, and then any sort of contingencies you have for those as well. So, you know, if this happens, we'll do this. A lot of times we're not going to go into a huge amount of detail with contingencies we cover at other places, but once in a while you get those weird methods that have specific things that you might want to consider or things that you've seen in your laboratory. Moving forward, waste management, you know, I'm not going to lie, I struggle with this one because I'm like, isn't it the same as pollution prevention? Maybe not. So you can, in my mind, you could combine those a little bit. Again, you're probably going to have another Another document that controls that, you can also reference that. Any references that you have, this is going to include the method itself. What method was this based off of? You might be referencing the standard. You might reference, regulations. So if there's something specific to this method that gets called out because of a regulatory reason, make sure you include that information as well. And then any tables or diagrams that you may have, flowcharts, validation data, all of that. Great to do is appendices as well. So one thing that I will say that most people don't think about is like when you're doing the distillation studies, let's say for ammonia or fluoride, and you have to have those on file, it's often a good idea to include those as an appendix to your quality manual so you always know where they are, because someone will ask you for them and you did it like 5 years ago and you're not exactly sure where it's housed. So if you put it as an appendix to your SOP, you know exactly where it is every time. So where does that leave us? Leaves us a little bit ahead of the break time frame, because my next slide goes into the next section. Can we go ahead and take questions now? Is that okay, Jennifer?
Yeah, totally. We do not have to stick to everything exactly. So we can be flexible here. We do have a couple questions, so I'll just go ahead and ask those, and then remind anybody if they want to put them in the Q&A chat box. Now's a great time to do that. Our first question is, how are TNIPT limits for ignitability determined?
Oh, wow. I'm not going to lie and say that I will tell you there's a committee that does that. But I avoid PT and PT expert committee meetings at conferences like the plague. So I cannot be overly specific with that. I know that within the FOPT tables, it does explain kind of how those are derived. Some not specifically to ignitability, but some of those PTs are based off of, a plus or minus factor. Let's say pH, it's plus or minus 0.1 units is what's acceptable off of the range. Sometimes it's standard deviations based off of the results that come back in. For ignitability, I don't exactly know, and I apologize that I don't have very specifics on that. But again, I avoid the PT stuff. I'm like, you put that into a table and I will utilize the table. But if you want to get involved, whomever asked the question, please feel free. T and I would love to have other people involved in the PT's portion. So next question.
Yeah. In regards to MDLs and SOPs, our recent audit stated we have to list the actual value, where before we referenced a document and LIMS. Where could you find the current, in LIMS where you could find the current value? Can you state where this is addressed in the T&I standard?
So I would have to pull it up and do some searching. I'm not, we've got a gentleman, Dr. Kircher from the state of Florida, that can cite things down to like the sub clause level. Here is what I tell you from the standard though. It requires that you reference your LODs, LOQs in the SOP, but it doesn't go into any details beyond that. So there are definitive things that we have to do in regards to how we do MDL calculations and all of that. But as far as what has to be referenced in the SOP, as far as the standard is concerned, it's not specified in there that you have to reference it. So in my mind, referencing that table would be perfectly acceptable, especially when we're looking at long list methods like your volatile methods or your semi-volatile methods, even metals methods where you have lots of analytes, listing those individually in the SOPs. Now, California may have a different perspective on this, and if that's the case, we've got some of those California ELAP people. So please feel free to speak up and correct me. I will also say, I'm up here live, but I'm going to throw this out there because I've done it at other conferences as well, is that when it comes to an assessment, you don't necessarily want to argue with your assessor on site. That doesn't make for a happy assessment for anybody involved. But deficiencies after the fact can certainly be contested and discussed with the accreditation body, or if it's a TPA through the third-party process. So that's one that I honestly would be like, hey, I referenced it. I can show you exactly where it is. I would push back on that. But if California, again, if you guys have got something a little more stringent that it requires it to be specifically listed in the SOP, please step up and let me know.
We have lots of questions coming in, so thanks guys for getting involved. So it says, hopefully this makes sense. I think it does. But if a COA has a quality test / release date of May 12th, 2017, and has a suggested retest date of May of 2022, can it be used beyond May of 2022 without retesting it? What does retesting look like? Or is there an expiration date based on when the standard is opened and any internal policies Like, for example, we used for 5 years if no expiration date is listed. Is that acceptable?
So that is very detailed. There's a lot of different components there. So let me try to hit all of them. So that suggested retest date, I wish I knew what kind of standard we were looking at of May 2022. In my mind, that May 2022 then becomes your expiration date for that particular standard. What does retesting look like? So that's something that you get to define within your quality systems and your SOPs. Like, if we're going to extend the date of a standard or reagent, how do we go about doing that? You sort of get to choose that process within reason, because if you get overly simplistic, recently it was, if my CCV passes, my standard or reagent is good, and we just move on with life. That's not acceptable. We need to be a little bit more detailed. We want to make sure that we're checking it against a standard that is not expired. I had that one as well once, where they were comparing expired standards to each other, and I was like, that doesn't work that way, folks. So you need to be realistic about that. I want to caution you as well, folks, because sometimes we like to take things and run with them. This does not work for microbiology. On the microbiology side, once something's expired, it's dead, we throw it out, it's done. There may be caveats to that, and if, then, buts, but I'm going to leave it kind of carte blanche there, that microbiology, this does not apply. So you get to kind of set that. Like, it moved. I had that all like on my screen and it shifted on me. What was the last part of that question, Jennifer?
Let me pull it up 1 second. It says, if they have an internal policy, for example, if used for 5 years with no expiration date if listed, is that okay?
So it used to be that under the old versions of the standard that if your manufacturer didn't come with an expiration date, that you had to set one internally. That was adjusted in the 2016 standard to allow for those things that, all in all, we're just like, this does not make sense. So there are some things that just don't go bad. They don't shift. They don't change. Salts of things. Diatomaceous earth, for gosh sake, it's not going to go bad on us. It's pretty stable things. So the standard did shift that. However, if you write into your quality manual that, we're after 5 years after opening, it's dead, we are pretty much, you then gave yourself a more stringent possibly requirement on some of those items. So once you say that, you must follow that. Would it be acceptable? Absolutely, for those things that don't come with an expiration date. I think it's a good idea to set dates within reason on things. Again, things like diatomaceous earth, it doesn't go bad. We understand. So I hope that worked for you. I think there was a clarification if I saw when I was scrolling through things on what it might have been.
Yeah, I think I have a little help here in the Q&A chat. So sometimes I get some people helping us out here. The next question, for method deviations allowed by earlier MURs, reduction of sample size, reagent size, which SOP section do you suggest that be included?
So method deviations is what we're looking for, right? It doesn't necessarily call out in the SOP where that needs to go. So you could be a little bit more flexible in that. You could create your own section by all means. You don't have to follow verbatim what's in the standard. You can create your own section for method deviations. I have a lot of laboratories that choose to do that. Scope and application or method summary, in my mind, would be a good place to do that right up front. We want to call out those method deviations that are allowed. And you were talking about specifically MER things, method update rule things, and those are certainly things that are clarified and allowed. Sometimes people want to alter methods that can't be altered. In that case, that's a different story. But if it's allowed, you definitely do have to call them out as deviations. Again, scope and application or method summary, either one would probably be a good place to do that, or create your own heading.
Okay. How does one avoid writing themselves into a corner when interpreting IC raw data, especially with an instrument that is finely tuned and responsive to any environmental changes?
Well, that's a very consultancy type question there. So I'm not going to go down and dig specifically into IC data in particular. We have a lot of broad reaching policies and procedures in our laboratories, and generally speaking, that's kind of where we want to stick with things. If you had more specifics about things you're concerned about, I might be able to be a little bit more detailed, but I'm not 100% certain where you're going with that. Again, you just don't want to get overly specific about any one thing. In regards to, again, something we can follow, something that's detailed to your laboratory, but again, don't write yourself into a corner with this specific item. Another example I have of writing yourself into a corner that just recently happened, was a laboratory actually wrote through their purchasing process. They named the person at the dock that accepted all of the packages. So Bob accepts the packages, and they were actually named in the SOP. And I was like, oh, we didn't do that. So I asked, hey, does Bob still work here? Oh, no, he retired 3 years ago. Well, you need to update your SOP, and we probably should use titles and not names in that regard. So just an example of how not to write yourself into a corner, but in regards to IC data, I would need more specifics.
So this question is kind of two-part. It says all SOPs need to have the TNI template 23 sections, and then all the staff has to sign on the cover page of SOPs annually after reviewing, even if no changes occur. So I think they're both just kind of clarifications.
Okay, so SOPs need to have the TNI template, those 23 sections. It probably is 23. They have to be addressed. And now the easiest thing to do, and the thing that's going to cause the least amount of heartache with everybody involved, is if you take every one of those and include them in so that we can follow along the line. I like to be the assessor that says don't do things just for the assessor. You have to address all of those items. Many of those are very clearly going to be called out. But again, pollution prevention and what was the last one there? It was waste management. I don't see why those situations couldn't be combined into one. I mean, they're very, very similar items. You're probably going to reference the same external document for both. So again, it's kind of your choice. You do have to address all of those items within your SOP. It may be easiest to list them out and include each one so that there's never any confusion about whether it was or was not addressed. But I will leave that up to you in regards to how you want to handle that. And then as far as all staff having to sign on the cover page of SOPs annually after reviewing, even if no changes occur, nowhere does it actually state that all staff have to sign off on SOPs. The person who is designating the SOP is being official, so your technical manager, quality director, whoever's signing off on the SOP to make it official, that signature has to be addressed. You do have to have documentation that staff has read the SOP, so that could be as part of a cover page, it could be an appendix, it could be a separate document for all intents and purposes. There's a lot of ways to go about that. There has to be a record of the review on an annual basis, even if no changes occur. So how you choose to have that record is truly up to you. There are a lot of options, a lot of ways to go about that. Things that we'll commonly see is maybe they actually do have a section that signs off on below. So you've got your initial signature, and then, on the next date, you've got the signature and the date and reviewed, no changes. Sometimes it's written in their quality system that they'll date and initial the SOP after they've reviewed it on an annual basis and there's no changes. You kind of have a lot of flexibility in how things are handled in your laboratory. Is it a bad idea to have staff read and sign off on SOPs on an annual basis? Absolutely not, even if there's no changes. It's always good to have that refresher of things, I would go as far as say, have them read your methods too. Again, not a requirement anywhere, but something that I would highly recommend, because we tend to move and shift and adjust things and kind of move away from that, oh yeah, this is why we're doing what we're doing. So it's not a bad idea to have them read them, but not necessarily required.
Great. Next one, it starts with 2 quotes from the TNI manual and then the question. So let me kind of just get through this. It's got TNI M1V2 and the chapter and verse. The internal audit program shall address all elements of the management system, including the testing and or calibration activities. And then TNI also method 1 volume 2. The internal audit schedule shall be completed annually. Do these 2 statements together mean that all of the certified methods and administrative and quality systems must be internally audited every year?
There's actually a standard interpretation request for this, Jennifer. So this is a great time to talk about that whole process within TNI as well. And I will summarize it to the best of my ability because it can be a huge nightmare. Essentially what happens with the standard interpretation request is a question similar to this will come into TNI. So it gets filtered in through TNI. There's a form you can fill out on the website. It goes to the Laboratory Accreditation Systems Expert Committee, and they determine whether it's a valid standard interpretation request or not. And then it goes to the applicable committee. So chemistry, this one would be a quality systems. It could go to microbiology, RadChem, whole effluent toxicity. It can go to a number of different places. The committee then as a group, and remember your committees are formed by, it's a cross section. So it usually 15 members, maximum 15. We try to keep it up there, and especially in our bigger committees, with a balanced representation of labs, accreditation bodies, and others. I'm an other as a consultant and an assessor. As a committee, we discuss it, we vote on an answer, and then it goes back through the process. So it goes back to the laboratory accreditation systems and then up to the states, and the states review that or that standard interpretation request. And then I will say like 90% of the time they veto it and send it back down and say, hey, we need you to change this, that, or the other. And the committees deliberate and we go through the process. And the idea being eventually it goes up to the standard interpretation request, goes to the AC. The AC says, yes, we agree to follow this. And then it gets posted on the website. So there is one in regards to internal audits. So I will summarize that for you. So when it comes to internal audits, you are required to cover all of your testing activities. TNI has determined this to be technology based. TNI works off of technologies, folks, so that's going to be like gravimetric, which would include TDS, TSS, total volatile solids, all those wonderful solids types things all fall under gravimetric testing. It's a technology. You know, your GCMS could technically be a technology. I would personally split that out into volatiles because that's a completely purgeable. Purge and trap is completely different than a direct injection system. So we want, and GC, we want to split that out to your ECDs, FIDs, those sorts of things. You can do it technology based. The caveat being with drinking water does require you to look at every method on an annual basis. So it's really going to depend in your laboratory what kind of scope you have and what needs to be looked at. You know, if you have a little scope, there is no reason not to look at every method on your scope on an annual basis. If you have a bigger scope, you're probably going to do more of that technology as you can, that technology-based type of things. And then to look again at your internal audits and what do you actually need to look at for each one of those. It can be, you know, covered by your laboratory. Obviously, things we want to do. We want to review the SOP on an annual basis. We want to make sure that, you know, we look at records at least on an annual basis, but how detailed that internal audit and for every method would be up to you. So I know that doesn't necessarily, we're good at not answering your question when we answer your question, but that's like regulatory and TNI speak. So again, not necessarily every method, but you do, as far as quality systems, we usually find labs that do one or the other. So they'll do a very good technical internal audit or they'll do a very good quality systems internal audit. We want to merge those into one happy internal audit, folks. And so you want to look at those things like, you know, reviewing your quality manual covers a lot of your quality systems. So if it's up to date and accurate and you have, you know, records that show that you're following things, you're probably pretty good to go. But you also want to look at, you know, sample receipt area. You want to make sure your reporting is going out accurately. And so all of those things get incorporated into your internal audit as well.
Okay. We have an easy one. I'll give you an easy one before we dive back into the deeper ones. How often should SOPs be reviewed per the 2016 TNI?
The wording is periodically. That's a fun one too, right? So what's periodically mean? It's going to depend on your program. So again, drinking water wants you to review everything on an annual basis. California may require annual review of SOPs. I don't know for sure. So again, if California ELAP folk have, you know, like extra things to push out there, please do. It does say periodic, so you have to set a schedule on how often those are going to be reviewed. Sometimes it's just easier to say, we'll look at each one every year, especially if you're a smaller laboratory. I have some labs that break that out even to like which SOPs are reviewed on even versus odd years. And I was actually shocked to find out that they did it because this lab had like 500 SOPs. I swear it was a rough week. So how often that needs to be done is going to be reviewed based off of partially your program. So drinking water does have to be on an annual basis. The standard requires periodic. If your state requires more often, then you have to do it more often. Fun times.
Awesome. Thank you, Michelle. We have another question. Can you tell us if it's true a small lab's QMS is less complicated than a large lab?
Not necessarily. Theoretically, probably, but not necessarily. Your quality system, everybody's quality system is based off of the same standards. So how detailed that is going to be based off of your particular organization and your needs. We tried to cover that a lot throughout our training process initially with you guys. Again, a larger laboratory is going to have more requirements and more things they have to address through their quality management system than say a small municipal laboratory would need to do. So that being said, if you're, you know, I really hope they rewrite their quality manual before I go back to see them again. I do have a municipal laboratory that has like a 200+ page quality manual, and it's a lot of repetitiveness and needs to be cleaned up, and it drives me nuts. But in their case, their quality management system is way more complicated than a lot of the commercial laboratories that I go into, just because they've kind of written themselves into that corner. So Generally speaking, you're going to go about things differently in a small lab. How you address things is going to be a little bit more simplistic, but not necessarily. What else we got?
Let's see. In general, let's see. In general, solvents such as methanol don't have expiration date, but some manufacturers started to have an expiration date, but can we ignore those expiration dates? This became a problem for purchasing nightmare that we can no longer purchase manufacturers listing expiration date on it.
Ooh, that sounds like an internal purchasing issue that needs to be addressed. If the manufacturer provides you with an expiration date, you must utilize that expiration date. That being said, expiration dates for some things can be extended, not microbiology. So in the case of like a solvent, those could be extended. How you go about that could be, you know, if we utilize it for a blank extraction and it comes back clean, then it's good, and we continue to use that particular solvent. It's going to depend on what your solvent's used for in your process. But generally speaking, when it comes to a solvent, we're looking for whether it's clean or not, how much it absorbs outside things that may be present in your laboratory. So I don't have a straightforward answer. I'm sorry, nothing in our world is straightforward. Everything's muddy, but in that regards, you can't ignore it. You could extend it after the fact, like we talked about earlier, but you can't ignore it.
All right. Thank you, Michelle. Okay. Well, that is just the beginning of what Michelle has to share with us. At this time, we're going to have a brief intermission so that Michelle can catch her breath and so that you can stretch your legs for a minute. Take some time to grab some water and get a little fresh air, but not too much because we're going to be right back here in just 5 minutes. We'll see you at 10:33.
Thank you.
Thank you, Michelle.
Okay, welcome back, everyone. I hope you had a chance to step away from your screen for just a few minutes. I'm going to remind you again to keep putting your questions in the Q&A box. We have a few that we didn't get to, and we'll pass those on to Michelle at the end of her next half. The more that are waiting for us, hopefully the more we can get to at the end of the presentation. Now we're going to welcome back Michelle to pick up where she left off. Take it away, Michelle. Oh, you're still muted. I see you talking, but.
Sorry about that. It happens. So next we're going to talk about control of records. And honestly, this is one that we covered before, and there's so much that goes into records that we want to make sure we covered it again, because it's a very common and easy way to have deficiencies in your laboratory. So let's talk about control of records. We'll move forward to the next slide. So records include, but are not limited to, folks, data, internal audits, management reviews, corrective actions, and preventative actions. That sounds pretty straightforward, but not so much. You must have a procedure to address how records are identified, collected, indexed, accessed, filed, stored, maintained, and disposed of. The procedures shall protect and back up records stored electronically and prevent unauthorized access to the amendment of the records. We want to make sure that we're storing records in a way that's going to keep them from getting damaged as best as we can. So we want to look at things like, are we flood prone? What do we do there? Are we something that we need to worry about in regards to, let's say like fires or hurricanes, those sorts of things, all things you want to consider when you look at those records and how you're going to store them. Generally speaking, when you're looking at the unauthorized access, a lot of times storing records in your locked facility will cover that. If it's electronic, how are those sorted into folders within your drive? Obviously, you don't want, the secretary at a different division being able to access your records that you have for the laboratory. So how are those kind of controlled within your laboratory environment? Logins and passwords generally work well. Positional access controls, such as separate server or folder locations, which only allows laboratory access. Functional access controls, such as read-only or read-write access. Again, password protecting those documents. You must set a retention time for your records as well. Standard requires a minimum of 5 years, but you need to know your regulatory requirements. Some drinking water require 10 years or more, depending on what you're storing those records for. So make sure you've got that retention policy set. Some laboratories choose to store, especially if you're municipal, you choose to store those records ad nauseum. So that's kind of up to you. You also want to make sure that records are legible and stored safely. So I talked about the safely aspect. Legible things we're looking at here is occasionally handwriting. So we want to make sure that we can all read our records. I did have a laboratory that actually did have a legibility, multiple citations for legibility because the analyst actually couldn't read their own records. So we do allow for some flexibility, and remember that you want to make sure that you write legibly. But this can also include things like again, them getting wet, those sorts of things. We want to make sure that you can always read those records. Next slide. I always, when I talk about records, because people want to know, can we go paperless? So I always try to address this as part of that records portion. Previously, I told a big story about the state of Kansas and all that. I'm just going to leave that alone, and we're just going to look at some of those things that we might need to consider before we go paperless in our laboratory. So it absolutely can be done. It can be done with a system like Qualtrics or some other sort of like a record management system. It can certainly be done without those things as well. I do have a laboratory that is completely paperless, that doesn't even have a LIMS system, and they do everything through like access databases that they've created and Excel spreadsheets that are locked and those sorts of things. So you can be creative in how it's done. It can absolutely be done, but it can also be a lot more difficult than you think. So some of the areas of the laboratory lend themselves to being paperless more than others. If we look at microbiology, for example, there are so many quality control records that have to be looked at through microbiology that it can be difficult to make that a paperless system. It can be done. I'm not saying it can't. Sometimes we have to be a little creative. We have to follow our procedures once we put them in place, but it can be difficult. A lot of times sampling is another one. You know, we're, especially back when I first started in the field, like if you had that thing, it wasn't a tablet back then, but if you had that thing that you could take in the field and enter all your information in, a lot of people just weren't comfortable with that. And so anymore, I think with our phones that are essentially computers in our hands, we're a lot more comfortable with taking things into the field to record information. But not everybody's comfortable with that, so we need to keep that in mind. You want to make sure, do you have room to store paper? If you have room to store paper, then maybe you go ahead and keep paper records. There's a beauty and a simplicity to paper records, but you know, we're all being more environmentally friendly. So you want to make sure that in regards to storage that we have enough enough storage space with servers or cloud-based technology, those sorts of things. How are you going to handle the sheer volume of data that you have? I will tell you that even from my aspect as a consultant and an assessor, like the sheer volume of quality manuals and SOPs that I collected over the years to review ahead of time, you know, those all get stored securely and password protected on my servers, but they're cloud-based, and the amount of data is unbelievable. Nobody should ever read that many quality manuals, but as assessors, we do. We also want to look at the LIMS system. If you have a LIMS system, it can certainly assist with this, but it's not necessarily required again. Ensure that all staff have access to the tablets, laptops, computers at the location where the record is and the work is done. This is one that we commonly, fall victim to, is that they're doing a particular step in another room where they don't necessarily have that computer with them, and they need to record, say, a reagent number. So I use this reagent as part of that extraction, and we don't have that easy access, and so it gets written down on a piece of paper and then brought back to the computer, typed in, and then the paper is gotten rid of, which you absolutely cannot do. So once it's written down, it's a record, you have to keep it. So make sure you've got access to those tablets, laptops, computers, technology at the location where it's done. And if you're going to keep scans of a paper document, which is what some people have chosen to do, we've got our chain of custody, it comes in, we fill it out, we scan it, we upload it into our LIMS system. And then whether or not you have to keep the original is going to be a lot of times based off of your regulatory requirements, either within the state or with your city or your municipality, where that data is used and what it needs to be used for. So whether or not you have to keep those originals is always kind of a question that you need to address with your clients. So again, you can absolutely go paperless. We're seeing more and more labs do this on a regular basis. Just again, the sheer volume of records, when you make that transition, you need to make sure that everything's getting captured within that paperless system. Next slide. So the goal for record management is to document traceability within your laboratory. You need to understand that all contributing factors that result in the release of final test reports to the customer is included in these technical records. It's going to include your test reports, all of your calibration records, your training and staff records. There's so much that goes into this that have to be maintained. You must be able to have an audit trail for all of your data, and that's a cradle to grave, folks. That's the time your sample hits your door through storage. Are the conditions met for storage, where the analysis, how that's all handled, and then the reporting as well. So all of that must be maintained. And you have to have your staff and training records as well. That 5 years that we talked about is 5 years from the date of last use, and that's something that we commonly miss as well. If you have a piece of equipment that you retire, that you're no longer using, you have to keep all of the records from that equipment for a minimum of 5 years. So don't throw out the maintenance records just because you're not using the equipment anymore. You still have to have access to all of those records. Training for staff as well, initial demonstrations of capability, even if they're more than 5 years old, those continuings that they do on an annual basis is based off of that initial. So that initial must be maintained. Sometimes we're grandfathering people in, and even with the TNI labs that have been around for forever, those records aren't necessarily there because it was done, they were grandfathered in 20 years ago. But as you move forward, all of those records need to be maintained. And it's 5 years past the date of last employed within your laboratory. So just things that we commonly forget when it comes to staff records and instrumentation records. Next slide. So common control of records, these are all areas, 413.2 for technical records, all areas of routine deficiencies. So original observations, we need to make sure we retain records of original observations. So don't write things down on scratch paper or post-it notes and throw it away. We kind of discussed that already. We want to make sure that we capture original observations somewhere besides like in a calculator. You don't want to put that, that value in the calculator, perform your calculations, and then just write down the resulting value. You have to have both information. This can also talk about like temperature records. We want to make sure that the original observation, so if you observe the temperature's at 35 degrees, but you have a plus 0.2 correction factor, you technically have to write the 35 and the corrected value of 35.2 because that 35 was your original observation. Analytical records must contain sufficient information to facilitate, if possible, identification of factors affecting the uncertainty and to enable the test or calibration to be repeated under conditions as close as possible to the original. If that sounds like standard language, it actually is. It's ISO 17025 language, section 413.2.1. What this is somewhat subjective, but the TNI Quality Systems Expert Committee is working on some guidance documents for this. It really kind of points to, I hate to say it, but it really is. It's a very generic area that leaves open for interpretation that a lot of assessors will point to when everything else fails. But again, if it's something that impacts your data, if there's a record of it, it has to be maintained. We want to make sure that everything you do gets written down. Do what you say what you do, and document it. Data must be recorded at the time it is observed. This is another one that we commonly miss. So we want to make sure that, like if you're checking pHs for a batch of samples, that you record the pH result at the time. So let's say it's a metal sample. You can't just put a generic heading at the top that all samples met the requirements. You actually need to have some sort of record for each one of those as you're doing that check. It doesn't have to be pH 1.2 for each one of those or whatever it is. You can simply have a check mark, a column that says, pH less than 2 and a check mark, but that observation needs to be recorded at the time that the data is the data needs to be recorded at the time the observation is made. Sampling times must be filled out when the samples are taken. So all those sorts of things are commonly missed. Next slide. Let's look at control of records. So 413.3 additional requirements. So all the language prior to this was ISO based. 413.3 is those additional requirements by TNI where we really specified down horribly, distinctively, very longly, what all needed to be included in those records. It does make things a little bit clear. It's still clear as mud. That's what we do in our industry. So we'll kind of go through these. It starts with A, with sample history. The laboratory shall establish a record-keeping system that allows the history of the sample and associated data to be readily understood through the documentation. This is a catch-all for assessors. Again, it's a very generic area. It's a very easy thing to point to. This can include things like reagents, things off to the side. Maybe it includes things like not recording temperatures like you're supposed to. We want to make sure that we can follow that sample through, again, cradle to grave, and it's a very good place to point to. You have to have those records, again, for a minimum of 5 years from last entry. We talked about that in regards to, like, say, maintenance records for instruments, training files, all those to keep in mind. You have to make sure your records are available to the accreditation body. So this is one of those things that it's pretty common sense, I would think, but when your assess AB is on site or their representative, that would be your third-party assessors if you're using them, all of your records do need to be made available to them. There are instances where we can take into account like confidentiality, things that may need to be like marked out in the records, all of that confidential business information, that can all be handled with your assessor or your AB, but you can't hide things from your assessors. You have to make sure that everything's available to them. Records that are stored only electronically shall be supported by the hardware and software necessary for their retrieval. So this one gets kind of fun in remembering that we need to, let's say we have an instrument that runs on Windows 98. If for whatever reason we retire that, we need to make sure that we can still access those records via Windows 98 in the future. So you need to make sure that computer stays around and that we can actually utilize it until your 5 years are up, or that information needs to be retained some other way so that we still have access to it. Access to archived information needs to be documented so that with an access log. So if you archive data, and that can be kind of subjective. So you choose to define how you archive data, but generally it's we box it up and we store it somewhere. Then when that data is accessed, you have to keep a log of who accessed it, why they accessed it, and when it was returned. A very simple way to go about this is to have even just a piece of paper on top of each of those boxes where it says, it gives you an opportunity to fill that information out if you have to pull those records. Most of the time, if you're pulling records like that, it's actually going to be during an assessment. So make sure if you do that during an assessment, that you fill out the form when you do it so that you have something to show your assessors. Otherwise, it's generally, maybe you're looking at data for an engineer, you're going back over what you've had for process control and you're going back into those archive logs to find information. We just want to make sure that, that you have that, if you archive it, that you have the record of that archive and who accessed it. Next slide. So all raw data, whether that's hard copy or electronic, we want to make sure that we have access to that. So here's what I will tell you is that with the raw data, this includes like if you're doing manual integrations, you want to make sure that the raw data is still accessible. Most software is a little bit more flexible these days than it used to be. Back when I started back in the day, we had to have a before and after, and a lot of times we still capture things that way where we have, we zoom in on the baseline, we show what it was before we did the manual integration, we do the manual integration, and we show what it was afterwards. We have to have that raw data, whether you access it electronically, whether you print things out, you have to have access to all that raw data. This is also where it falls that we can't use those pre-programmed calibrations within the instrumentation that we sometimes see with like spectrophotometers, colorimeters, those sorts of things. Some of those come with, and I'm trying very hard not to name names or point fingers, some of those come with those predefined calibration curves. You have to have the raw data from the calibration. So if your manufacturer can provide you with that, then great. But I will warn you that most of the time that is not the case, that they can't provide you with that information because that was one of 100 that they did that day and they don't know which one was where. Or whatever their reasons are, but we want to make sure we have all that raw data. You have to have a written description or reference the specific method used. So this is going to be, as a standard methods 5210B, approved in 2016, or was it, and this might also include your SOPs that you want to make sure you reference exactly what it was. If you reference your SOP, you are by default referencing your method because your method's included in the SOP. We want to make sure that all of your records have, especially your analytical records, can reference back to the method that was utilized. It's pretty straightforward. The sample ID code needs to be as part of that data. We want to make sure that we can track that data through the system and we know what each portion of what we're looking at, what samples does that apply to. The date of analysis, that's pretty straightforward as well. We need to know when it's done. And the time of analysis must also be recorded if the holding time is 72 hours or less. So that's going to be like your short hold samples, even your 24 or 48-hour holds. Those need to have a time associated with them. Your immediates as well. So let's say pH is one of those that has to be done within 15 minutes. If for whatever reason, which most of the time once it gets to the lab, you're beyond that, you still have to have that time recorded and the data must be flagged for being outside of that time frame. You also have to record times if time critical steps are included. So that's extractions, digestions, incubations. This is also going to include some of those random tests that have those very time specific things. I usually point to 4500 PE, which is a phosphorus method total. And I will tell you that this method, it's very straightforward. It's pretty easy to follow. It is so robust and provides extremely accurate data. But there are some pretty specific requirements in regards to time. So like your color reagent is only good for 4 hours. So now we're not only looking at the prep date of that reagent, we need to know the prep time and the time it was utilized. It has a sitting time. Once you add the reagent, it has to sit for 10, but no more than 30 minutes. So you need to make sure that you can track that through your records. Sometimes we can lump times together for things, but you want to make sure that we are very specific when it comes to the actual sample itself, like when was it analyzed, and that we're within those hold times. Next slide. Instrument identification, instrument operating conditions or parameters, or reference to such data is what that is. So what we want here is we want to know when we look at a specific piece of data, if you have multiple instruments that it could have come off of, we have to be able to track it back to the specific instrument that it was ran on. And if you don't, if you, let's say you have like 3 GCMSs, we could name them Bob, Susie, and Mary. And you could refer to them that way. You can give them serial numbers. You can say GCMS 1, 2, and 3. If you've only got one item in your laboratory, you still have to ID that instrument on your system, so it's, UV spec, whatever. Those things need to be included as well. Operating conditions, sometimes for simplicity's sake, for like a spectrophotometer, that might be what wavelength we utilized. We need to have that included in our records. When it comes to our more instrumental type analysis, a lot of times that information is included both in the SOP and through the raw records on your data files. You don't necessarily have to print out the operating conditions every time, but you have to be able to access them for that specific run with that sample was included. So make sure you have access to that information. All manual calculations, and this includes your manual integrations. We want to make sure we have records of all of what happened there. Your analyst ID, of course, we need to know who ran it. So especially if you have multiple analysts, we want to make sure that they're identified somehow. That could be, initials. It could be the actual name of the analyst. Whoever you choose to track that through your laboratory. At some point, you're going to need to have, there's a requirement, and it's buried in the standard now, where you need to have that record of, the name, the signatures, and the initials, so that then we can pull that record and compare it to whatever, because I will tell you that sometimes people's initials look nothing like what I would expect them to for their name. So I'm like, who's RG? And it ends up, his first name's Thomas, but he goes by Robert because that's his middle name. So he does RG for his initials. That doesn't help me. I'm looking at the list of names and going, I don't see Thomas anywhere. Like, who is RG? So make sure that we have that information and we can track it through your system. Anything in regards to sample preparation, that includes any cleanup steps you may have, separation protocols, incubation periods, subcultures, ID codes, volumes, weights, instrument printouts, meter readings, calculations, reagents. Anything that goes into sample prep must be recorded. Of course, your test results, you have to have a record of test results, whether that's from the instrument itself, the raw data, if it's handwritten on your bench sheet, however that is, there must be a record. I mean, that's pretty straightforward. It goes into a report too, at some point, some form of a report. The standards and reagents used, their origin, receipt, preparation, and that use. So we need to know, what was that standard? You need to be able to track that back through your system. So again, cradle to grave. So when did it come in? What is our ID for that? That might be a unique ID we assign as a laboratory. It could be the lot number from the manufacturer. We want to know when it was received, how we prepared it. So if we made a dilution, that needs to be recorded in a prep log somewhere, somehow. And then anytime we utilize that within the laboratory, that data needs to be linked back to the samples that it was utilized with. Next slide. We're still talking about records, folks. Calibration criteria, frequency and acceptance. So we need to have a record and traceability for that. So what are we looking for? How often do we have to calibrate? Is it a daily calibration, like some of our, let's say like seals, a lot of the AAs, some of our metals instruments, we do a daily calibration. Some of our GCs or HPLCs, we might hold that calibration. IC might get held for, when I worked back in the day and I did organics, I did repro work. And so my instrument was always dirty because I ran extremely dirty samples. So I calibrated as needed, which happened to be like every couple of days, whereas a drinking water laboratory might be able to hold a calibration on a GC for, months. And the first time I ran into that, I was actually shocked. Like, you can hold your GC calibration, and I was like, you have clean samples. That I get it. I understand now. But we need to have that, frequency, generally speaking, that's going to be at least once a year. We want to recalibrate at least on an annual basis. And then your acceptance criteria, what are we looking for? What's a pass versus a fail? You can certainly point to the SOP. Here's what I will warn you is that you want to make sure your analysts know what the acceptance criteria are. So sometimes it's easier to put that in, say, a bench sheet. If we're doing something that has a bench sheet, it's nice to have that, in like a cover page, maybe for your organics data, those sorts of things. One, it's easily accessible. It's easily, they can look at it on a daily basis and be like, oh yeah, that's what it's supposed to be. But also when your assessor is standing there and they ask them, what's your acceptance criteria? They have something to look at when they go blank and they go, I don't know. The I don't know is not a good answer when it comes to acceptance criteria for calibrations. So sometimes it's a little bit easier, one of those tips to make sure that's easily accessible on their records. Data and statistical calculations, review, confirmation, interpretation, assessment, and reporting conventions. Oh, that's a whole lot of information to say, your data needs to be, you have to have records of anything that happens with your data, QC protocols and assessment, and then electronic data security, software documentation and verification, software and hardware audits, backups, and records of any changes to automated data entries. That last one in regards to electronic data security, that's a whole lot of words, and I am not an IT person, so here is what I can tell you about this. Where this comes in is looking at, say, spreadsheets, and understanding when a spreadsheet needs to be validated and when it doesn't need to be validated. So very simply, if you use, let's say, the sum or the average feature from Excel, where you're not actually, you just say, sum, and then you highlight those cells and it gives you a number, that doesn't need to be validated. If you say you're going to sum it and then do this and then do that, now you've created like a string of things, those need to be validated. We want to make sure that if you have a LIMS software and you have calculations in your LIMS that you've inputted, that those get validated and records are maintained of those validations. If you are storing things only electronically, this is where your data security falls into making sure that it's backed up. So you have to have a procedure for how it's going to be done. And then you want to make sure that there's actually a record of those backups happening. A lot of times when I ask in a laboratory about that, they're, oh, IT does that. 90% of the time IT is, grumbles, but will provide you the record because they have a record of it somewhere. Once in a blue moon, I've actually had a laboratory find out that they assumed things were being backed up and they weren't. So just all things we want to double check on when we're going through that process. But again, records must be maintained of all of that fun stuff as well. Next slide. We're still going through these records, folks. Method performance, including calibration criteria, frequency, and acceptance criteria. I think, is that a repeat? Nope, sure isn't. Data and statistical calculations. We want to make sure we review confirmation, interpretation, assessment, reporting conventions. That's all repeated. We'll move forward. Method performance criteria. So expected QC requirements. Oh, not with the slide. I'm sorry, with me. Proficiency testing results. We want to make sure that those results are available. So you've got your report, right? You have your data. You run your PT samples. We treat them as similarly to regular samples as we can. And that's a whole presentation in and of itself, folks. But we want to make sure that we have the records of all of that. So when it was analyzed, when it was ran, we keep those results. And then when we report it out to the PT providers, we want to make sure that we have records of that as well. So it's always good to print out what you entered in if you can, and then actually confirm it before you hit the send button so that you don't have those typos that go through. Records of demonstrations of capability for each analyst, and then records of names, initials, signatures for all individuals who are responsible for signing or initialing any laboratory data. And this is where I was talking about that, that form where you have the name, the signature, the initials, so that we can track it all through when it doesn't actually make sense. Warning here. So when you have name changes, whether that's some sort of a legal name change where their signature is going to change, a marriage, a divorce, an adoption, all kinds of things can happen there. If your name changes and what you sign changes, there needs to be a record of that change happening as well. So, if Mary gets married and Mary has a new last name, make sure she re-signs everything with the new last name and the new initials that she's using so we can track that through and we don't get lost. All right. Next slide. So things do need to be, records must be legible, so they don't do any good if you can't read them. We talked about legibility and making sure that they're, the biggest thing when it all comes down to it is that you at least need to be able to read those records. Ideally, people in your laboratory can, and it's really helpful if your assessor can read your records as well. So make sure that we're being legible when we write things down, that we don't, set cups of water on top of records and you get the bleed through with the ink, any of those sorts of things. I actually have an example from my own life and as an assessor or as an AB, where again, our records are maintained. As an assessor, my records are maintained as well. But I had, I get poison ivy like really, really bad. And I can look at it and I get poison ivy, but I had poison ivy down my arm. I'd use an alcohol-based anti-itch on it. And then I set my arm down on my desk and it happened to be right on top of a laboratory's checklist from an assessment. And so all of a sudden, like all of that information transferred onto my arm, and I panicked because I have to keep a record of what happened. So I'm not gonna lie, like I actually ran to the photocopier and like copied my arm and then put it on there with a corrective action form because I didn't want to get nailed for not having that original record. It was probably a little bit overkill in that regards, but again, original records, folks, things have to be legible. Don't lose the information if you can avoid losing it. I was also very careful about setting my arm down after that when I was in my office. So you also need to address potential transfer of ownership. So we want to make sure that if your laboratory is going to shift, let's say it gets bought out, you close down, whatever happens, that you know what we're going to do with those records. So we can simply state it in our quality manual. For municipalities, let's be honest, generally speaking, the city is still going to maintain those records after you close ad nauseum for years. They seem to have like an infinite hole, the cities do, where data goes, and they can still pull it out, but I don't know where they find all the storage, but they do store things like forever. For your commercial laboratories, it's a little bit different. There's things that we need to consider there. Like if we're going to close down, what are we going to do with that data that does have to be maintained for 5 years, and how are you going to handle that? Next slide. So common deficiencies, we covered these in the original training, and I still think it's very good to go back over them. It highlights those areas again where there's common instances. So obliterations, there's an example on the screen of obliterations. We want to remember to single line, date, and initial all corrections, folks. Don't like mark through it. Don't overwrite things. We had a legal issue with a laboratory, and it was like over pin smudges. So be mindful of pin smudges. That's a whole discussion over drinks some night too, and pin smudges. But make sure things that aren't obliterated, that they're easy to read. Legibility again. Records aren't maintained that need to be. So that can be a lot of things, but generally speaking, what we're pointing there is don't throw away post-it notes or hand little notes that have data written on it that you observe. So those original observations that get recorded, if you're recording it on a post-it note, that needs to be kept. So you can tape it to your record if you have to. I'd find a better way to go about that, but you do have to maintain it one way or another. And we want to make sure that observations, those records of those observations, are recorded at the time they're done. So again, no lining down for preservation checks on sample custody forms, no blanket statements about preservation in samples or pHs being listened to for metals. We want to make sure that each one of those is marked individually in some form or fashion when that observation is made. Next slide. Yay. Records. So we covered all of the record stuff. There's still a ton of record questions, I'm sure, and we can put them in the Q&A, and I will get to as many of them as I can. Records is so wide and so huge, but we're going to focus in a little bit more, and we're going to look at calibration requirements from section 5.5 of the standard. So calibration is based on a reference standard. You're comparing the performance of the unit under calibration. Through comparison, you can determine the accuracy and error, or how far the reading is from the true value. So when we look at the difference between calibration and verification. So we're looking at how far it's off from that true value. The process is not in there during calibration. We also consider traceability. We want to make sure we have that unbroken chain of comparison linking to the highest level, your reference standard, and hopefully back all the way to NIST if we can. And then computerized measurement of uncertainty as well. So without these two, we can't call it a calibration. We're just performing a simple verification. So that's a calibration. We're actually looking at comparing it to a standard itself. We're looking at verification. On the other hand, verification is confirming the performance of the instrument based on given specifications or requirements. We're going to look at ensuring the instrument is working correctly for its intended purpose. And generally with a verification, we're not checking the entire range of what we're doing. We're looking only at those areas that we actually utilize that specific piece of equipment in. And we're directly deciding what to do based off of that verification result. When we do a verification of an instrument, we may find that we actually have to recalibrate it. So this can be something, this is a pretty straightforward process. If we look at like an instrument where you do an initial calibration and then you do a calibration verification, a CCV standard. If your CCV passes, you move on. That's your verification. If your verification, your CCV fails, you go back and you have to recalibrate. So it's as simple as that. We're looking at things in the laboratory. It's kind of like if you have a digital thermometer that you do a calibration on, generally we send those out for calibration. It's way easier to let that ISO accredited calibration body to calibrate that reference thermometer for you. But they're actually going to look at it over that entire range. They're going to give you correction factors that are based off of, degree increments, those sorts of things. Generally speaking, when we look at calibrations, what we do are verification thermometers in-house, we verify them. So we verify at that range. So if we use it at 35 degrees, we check it at 35 degrees. It may actually go from like 0 to 50, but we're only looking at that little range. So calibration versus verification, everybody at HLA wanted me to be sure that I covered that a little bit with you guys, because it can get tricky with the wording and understanding what happens as we move forward. So next slide. 5.5 and calibration requirements. So you must have the necessary equipment to perform the analytical tests on your scope of accreditation. That's pretty straightforward. It's pretty understanding. You don't dry lab your results. It's not a good thing. So make sure you have that equipment and that it works, folks, especially when your assessor's on site. The equipment must be of an accuracy required for the specific test. So this comes into play. Generally speaking, we purchase those things. It's not an issue. We haven't seen it in California labs any more than we have anywhere else, folks. So I'm not trying to pick on you. I'm just pointing things out. We want to make sure that the equipment meets our needs and the needs of the test and the needs of our clients. It's pretty straightforward. They do have to be calibrated before use and anytime it leaves your controls. So we want to make sure that any of our equipment, be it instruments or support equipment, get calibrated. They have to have a procedure for verifying and validating it. They do need to be uniquely identified. Again, I talked earlier about like maybe you have multiple GCMSs. The same thing goes for thermometers. We take temperatures and have thermometers located throughout the laboratory. Each one of those thermometers needs to have some sort of a unique ID, whether that's a manufacturer's serial number, an ID that we assign to it and label it with. Everything needs to be uniquely identified. We need to make sure we have use and maintenance instructions for all of our instrumentation as well. So we want to make sure that we know how to utilize it. Sometimes we get the handy little books in the pamphlets. More and more often, people are pointing you to a website for a PDF. I would highly recommend you download those and keep those in a file on your hard drive, just in case for some reason you don't have internet access. But make sure you have access to those maintenance or use and maintenance instructions. We want to make sure that our equipment is authorized or used by authorized personnel. So peer personnel that have demonstrations for capability and know what they're doing, and that your instrumentation is labeled or coded. You must have a calibration or policy procedure for all equipment. That includes all of your support equipment, all of your instrumentation, obviously. Equipment must be calibrated before use and every time it leaves your control. Again, sometimes I repeat myself, but it's all very important information. And sometimes if we say it over and over again, it sticks a little bit more. Michelle kept saying this, it must be important. Instructions need to be available and that equipment needs to be uniquely identified. Next slide. Look at that, somebody went in and made my boxes like color gradient. That's pretty. So when looking at, too many words, need graphics. When looking at 555, records must be maintained for each item of equipment and must include the identity of the item of equipment and its software, the manufacturer's name, type, identification and serial number or other unique identification, checks that the equipment complies with that specification when it comes in, the current location where appropriate. So if you've got like say pH meters in multiple laboratories, we need to know where each one is located. The manufacturer's instructions if available or reference to their location, dates, results, and copies of reports and certificates of all calibrations, adjustments, acceptance criteria, and the due date of the next calibration. Maintenance plans where appropriate and maintenance carried out to date. So you do have to have records of your maintenance, and then any damage, malfunction, modifications, or repair to equipment, all things that we need to have records of in our laboratory. That don't make it any more complicated than you need to, folks. A lot of this information, when you get a new piece of equipment, it comes in with it, and you simply put that in a file, right? And you keep it there where you can access it, where you know where it is, please know where it is. But again, it's usually, it sounds way more complicated than it actually is. Next slide. 5.5.10 and moving forward with the standard. When intermediate checks are needed to maintain confidence in the calibration status of the equipment, these checks shall be carried out according to a defined procedure. So you have to have that defined procedure for those verifications that happen with any of your instrumentation, be it, again, analytical instrumentation or support equipment. Where calibrations give rise to a set of correction factors, the laboratory shall have procedures for ensuring that copies, for example, like computer software, are correctly updated. So if you have a correction factor for an instrument that needs to go into your LIMS system, then it needs to be put there and you need to update it anytime that correction factor adjusts. Generally speaking, in our facilities and what we look at, correction factors generally point to thermometers. So we want to make sure that we have that unbroken traceability of the correction factors with thermometers from the verification records clear through, being listed on the thermometer itself and then the record of the temperatures being taken. 5512 requires that test and calibration equipment, including both hardware and software, shall be safeguarded from adjustments which would invalidate the test and or calibration results. It's pretty straightforward. Again, we usually have our equipment in a locked facility. We don't let people in to just randomly play with things. I will say from personal experience, if I could have, I worked in a pharmaceutical lab for a few years, and if I could have, I would have kept our quality control VP, whoever he was, out of the laboratory, because he would come in and randomly adjust things in the laboratory to make sure that we were checking things every time. And a lot of times he would just kind of blow our instruments out. So if we could have kept him out of the laboratory, it would have been great, but we didn't have something like this to point to say you can't do that. So again, let's, within reason, make sure we keep that from being adjusted. Next slide. 5513 in regards to support equipment. It's a critical portion of the standard and refers to support equipment, which includes, but is not limited to, folks. This is an incredibly long list of things. Balances, ovens, refrigerators, freezers, incubators, water baths, temperature measuring devices, including thermometers and thermistors, thermal pressure sample preparation devices. If you don't know what that is, count yourself lucky. If you don't have to do ZHEs, you're a very fortunate person. ZHEs are no fun. Mechanical volumetric dispensing devices, such as Eppendorf's or automatic diluter dispensing devices. When it comes to particular disciplines and the requirements, there are generally additional information in the technical modules, particularly for microbiology folks. So we cover generics in section 5513. Micro will kind of define things a little bit more clearly, and I will talk about that a little bit as we go through things. Support equipment is generally the ancillary equipment. It's not generally the things that we're actually measuring. They're the things that we check beforehand. So it's going to be our balances. Again, we weigh things. Balances are tricky though, folks, because if you're using a balance for gravimetric, it is now an instrument and not just support equipment, because it's actually where we get our information. So sometimes they float between. We have to have calibration and verification procedures and required specifications and procedures for these, and required specifications of acceptance criteria. We have records of the maintenance and repair of our support equipment. It's very easy for us to remember that, hey, our ICP needs a log, a maintenance log, but your support equipment does as well. So anytime you do, let's say a water bath, you change the water, you should probably keep a record of that. It's pretty simple. You keep a little book, you can mark it off, you can write it down and say, I changed the water on this date, I cleaned it on this date. This can include refrigerators, folks. Anytime you do a defrost cycle on your refrigerator, especially if you've determined that to be a preventative action for, hey, it froze up. So we need to do defrost our refrigerator on a every 6 months. Well, then you need to have a record of defrosting your refrigerator on every 6 months. So those pretty straightforward things we should also keep records of, just so that you can point to it and say, hey, yeah, we did that. Things that are used on a daily basis must be checked on each day of use. That includes your balances, ovens, refrigerators, freezers, incubators, and water baths. All of that information must be checked and recorded on a daily basis when in use. And in use can be tricky. We'll get to that too. Next slide. So let's start with temperature measuring devices. Remember, that's thermometers, thermistors. There's probably some others out there. You can have digital, you can have, your old mercury ones, you can have alcohol-based ones. There's all kinds of things out there in different specifications, but these are more generic. So if the temperature measuring device is used over a range of 10 degrees or less, then a single point of verification within the range of use is acceptable. Remember that verifications for these must happen on an annual basis, at least an annual basis. If it's more frequently than that, it's generally you're pointing to a regulatory requirement for that. Drinking water, for IR guns with, I don't know if California's becomes a shall state. Some states are, some states aren't. Drinking water IR guns, they want you to check those on an every 4 months basis. If you're doing DOD work, that's going to be defined within DOD that you have to do that. Other times it's like standard methods, depending on your version of standard methods, but for microbiology, we'll say every 6 months. Sometimes it's a requirement, sometimes it's a should, but we want to make sure that at least annually we're verifying those thermometers. So 10 degrees or less than a single point. So let's say your refrigerators. I will often tell you that the standard's written for people who, for assessors who overutilize the standard, and for laboratories who underutilize the standard. This specificity actually came from an assessor who overutilized the standard and said that our refrigerators are good from below freezing to 6 degrees. So you must check it over that entire range. And we all kind of went, why would you do that? Like, that's silly. So we specified 10 degrees or less. You can do it at a single point within that range of use. If it's greater than a 10 degrees, then you must your verification must bracket that range of use. So a lot of times where we see that will be like an oven that gets used for both TSS and TDS. We want to make sure that we check it at both of those temperatures. Next slide. When we're looking at volumetric measuring devices, this can be disposable or single-use volumetric equipment, and those things such as disposable pipettes, digitubes used for metals digestions, those sorts of things must be verified once per lot. The digestion tubes for metals is a common one. People like to point to their certificates. Under the standard, you're not allowed to use a certificate for that. You must actually verify those volumetric markings when they come in. If you are using multiple volumetric markings on that tube, a lot of times it's like the 50 mil mark or the 100 mil mark that we're actually utilizing for some sort of a disposable thing. But if you're using multiples, we want to make sure that you check it at each one of those. And that can be done either with like a Class A glassware. It could be done gravimetrically with a balance. There are little variations in how you can do that, but it has to be done once per lot. Mechanical devices, so that's going to be, again, your anything mechanical, so your adjustable pipettes. This also kind of applies, unfortunately, to your auto diluters on things like your metals instruments or your, let's say, your seals, your AAs, your auto analyzers. Those, if you're using the auto dilution function, that has to be checked on a quarterly basis. Mechanical devices used at more than one volume have to be verified over the range of use, just like with a thermometer. But the standard specifies it a little more clearly with the use of a low, a midpoint, and a high point within that range of use as well, in regards to our volumetric equipment. All other support equipment shall be calibrated or verified at least annually using a recognized National Metrology Institute such as NIST traceable reference when available, bracketing that range of use. I have a picture of a balance up here. It was a stock picture of a balance. This looks like very infrequently does that look like the balances we use, unless you're doing large volumes, which some of you do for soil labs. But our balances are one where we typically fall short with this. So we're very good about having somebody come in and check our balance on an annual basis. What you want me to be mindful of is that they actually check over the whole range that you utilize. So if you are, for whatever reason, doing a huge broad range, remember when they come in and do that check, that they check over that huge broad range as well. On your daily basis, you're doing that verification at the measurements you use. When they calibrate it on the annual basis, it's going to be that big wide range. Raw data records shall be retained to document equipment performance. So it's just saying that you have to have records of any calibrations, verifications, or maintenance. Again, those records, part of it, need to be maintained. And looking at support equipment, one of the things I didn't touch in there, and I told you that I would, was in regards to temperatures on every day of use. So where we commonly see this fall, and my chair is shrinking as I sit here, so let me adjust my monitor. Where we typically see this is things that happen over multiple days. The thing I will point to very quickly is BOD incubators, every day in use. Refrigerators where you store reagents or let's say your control organisms for microbiology. If it's in there, it's in use. So if you store samples over the weekend, if you have standards or reagents over the weekend, BODs over the whole 5 days, you do have to have a record of the temperature every day that it's in use. That being said, I'm not asking you to have somebody come in on overtime on the weekends just to record the temperature of your BOD incubator. There are other ways to go about that, such as using a min-max thermometer. Data loggers are another great way to do that. If you use a data logger, you must go in and check that temperature with the data logger on a daily basis. So when you come back in on Monday, make sure you go back in and actually have a record where you checked it. Just saying that I have a data logger and it sends me an alert if it's outside of the range is not sufficient. You actually have to go in and make sure you check it. So another, tips, words of wisdom, those sorts of things. And I believe, where does that leave me time-wise? I have to do the math on time zones.
We have, I don't know, we can give you probably another 20 minutes or so for presentation and Q&A. So.
Okay, well, I believe we go to the next slide. I believe that was kind of the end of my presentation. Yep, there's our information. That's the generic information. If you want to get something to me, it's mWade@HLAworkplacetraining.org. If you send it to them, they'll forward it to me because none of them want to deal with the environmental stuff. They just send it all to me. Michelle, you deal with that. So there's our contact information. If you'd like to reach out to us, we do, of course, a little shameless plug for HLA Workplace Training because, I spent all this time talking with you guys. We do, of course, consulting. We'll do individualized consulting. We also teach courses, so we'll individualize training for your laboratory. A lot of times we actually incorporate that into our consulting, so we don't just like go in and fix things for you. We actually train you so that in the future you can do that. But we customize all of that to each laboratory as we go in and do that. We have a wide range of consultants over all sorts of things, but especially within that environmental industry, we have access to a lot of people through HLA Workplace Training, and we're always looking to, fit the right people with the right people. So we don't give, the really mean consultant to the really, really nice people that are going to cry when this consultant comes on site. We look at all of those things. But I am more than happy to answer questions that you may have. And I think there's a lot of them over there.
Okay, well, let's just rapid fire get to them. As a consultant and an assessor, how do you address protection from conflict of interest?
And I actually just dealt with this, so that's a very timely question. So a lot of times, and I'm not 100% sure on California and their regulations, most of the time it's a 2-year window for us as a consultant and assessor, if you're talking specifically about me, is I have a 2-year window from the time that I do an assessment or that I consult with the laboratory. From the end of that, I can't do the other type of work for that laboratory within 2 years. And so I just had an instance where I had been into a laboratory at the end of last year. I did their assessment. Their laboratory actually moved. So the AB came in and did a follow-up assessment with them. And through that follow-up assessment, they found a number of items that didn't get taken care of when they moved, and they recommended the laboratory get a consultant. And so the laboratory was like, it would be great if you could come in and do it. We're used to you. We love you. You've helped us out over the years. We'd love to have you as a consultant. And I had to step back and say, I'm sorry, I can't. I just did your assessment like a year ago. You have to find somebody else. And so sometimes it's a financial conflict of interest. A lot of times it's because, we're taking the knowledge that we gained and then utilizing it for our financial gain and doing that consulting aspect. So from the assessor and consultant, when I'm working on both sides of the house, which I frequently do, I have my list of laboratories and they don't cross. And so especially like with California, for the most part, they do not assign me to California assessments because we've done a lot of work on the workplace training side of the house for consulting with California labs. And they want to leave me open and available for doing that sort of work instead. So we're very mindful of where we assign staff on either side so that we don't have that conflict of interest happen.
Awesome. Can archive data be digitized?
More than likely, yes. So again, it's going to depend on your particular regulations and requirements, but I would have no issue with that. Again, if you digitize something, once it becomes digital, backup records become very, very important. So not only, I think IT backs it up, we want to make sure that IT backs it up and there's a record of that happening and that you can access it for that minimum amount of time. So if it gets, stored in some format that needs a special software, that software is always available for it.
Okay. Are the COAs considered part of the data packet?
Well, data packets, that's a little broad. I will say if you're looking at like from a commercial standpoint what a data packet is, it'll depend on the level of the data packet. So are COAs a record that are necessary? Absolutely. Does it need to be included in a data packet? That's going to depend on your client's needs and how things were defined. So I will tell you, like, I think it's like a level 3 and above data packet if you're working like in the as far as like the engineering type firms, those sorts of things. Generally that COA does have to be included with that. But again, it's going to be defined by your client, whoever you're producing that data packet for.
Okay. We use hand meters for some tests. They are calibrated by the manufacturer. Per your comment about raw data, we should request the calibration from the manufacturer?
So absolutely, you should request, and depending on who that's provided to you from, you may or may not be able to get that. So I would, again, be mindful of where things fall within things as well. So if you are doing a field test, there may be very different requirements if it's not on your scope as far as like your TNI -2 status. There may be different acceptability and criteria for those field parameters, and so that's where we commonly and a lot of the TNI states even we point to that and say, hey, you know, maybe we don't put that field test on your TNI scope of accreditation, because now we're requiring a lot of different things that wouldn't necessarily have been there had it just been a field test and covered under other regulations. So if there's a calibration associated with a piece of equipment, you have to have that raw data for it. A lot of times what we can do is we can actually, even if they have that pre-calibrated instrument, is that we can create our own calibration. It depends on what you're using it for. Like the chlorine, the pocket kilometers for chlorine are a little bit different. Like those, I don't believe we can calibrate. You might be able to. Sometimes you can override their calibrations, and other times you're verifying them. If it's a spectrophotometer where it's pre-calibrated and you run standards, you can create your own calibration curve through like Excel, y = mx + b, right? And do your calculations just like old school chemistry class. There are ways around a lot of it, but we do have to have the raw records for those pre-calibrated instruments, and generally they can't provide them. Sorry.
Just to confirm, if we calibrated a thermometer at 35 Celsius and it's used for 35 and 44.5 Celsius, would that be a finding, or since it's within 10 degrees C, are we fine?
So 35 to 45.
44.5. So
Oh, 44.5. Technically, if it is dead set 35 to 44.5, then no, you would not. Now we're talking microbiology, because we all know where those temperatures come from. That's a micro thing. The 10 degrees actually came from the micro environment, folks, because when we looked at thermometers and what we were going to do, we looked at it across the board, and the micro people came back and said, like, you cannot use that thermometer for total coliforms and fecals and not check it at both temperatures. So if we look at the range, it's 35 plus or minus 0.5 degrees would be 34.5, and then it's 44, you know, plus or minus 0.2. So you're just outside of that range if you look at what's acceptable for the method. So keep that in mind. You're pushing envelopes, and don't push envelopes too far in regards to especially public health concerns. So technically it's 10 degrees, folks, but be logical about it.
Do mechanical micropipettes have to be uniquely identified and linked to a specific batch for historical reconstruction?
So mechanical micropipettes. So if it is, we'll step back just a little bit with the mechanical devices. So Class A glassware, when we're looking at volumetric, Class A glassware and glass microliter syringes are segregated from the additional verification requirements. So, and that's microliter syringes, folks. So if your syringe goes above 1 mil, you're no longer a microliter. It's a milliliter or above at that point. Everything else does have to be verified on that quarterly basis. It does need to be uniquely identified. As far as being linked to your specific batch for historical reconstruction, yes, within reason. It's tricky. It's lab-based. You know, if you've only got one in the laboratory, it makes it a little bit easier. If you're talking about your auto analyzer and your mechanical, which you're talking about micropipettes, so not necessarily, but ideally, yes. But that being said, we also don't have to get ridiculous in that we give each one of our graduated cylinders an ID, and we write down a graduated cylinder ID for each one. Again, you know, when you're pushing the envelope, don't push it too far, but also don't like shove it across the room and make things impossible for you. So hopefully that helps.
Okay, if our LIMS calculates TN automatically, can we have a program written by IT within the LIMS to validate itself rather than a human validating the calculation? Or can we validate the first 5 times that automated calculation is performed by LIMS and then consider it validated?
So when you're validating like the LIMS calculations, you have to have a record of that validation happening. So I'm not an IT expert. I can't tell you 100% whether or not that IT LIMS software thing would work or not. It depends on whether there's a record and how that's handled. Certainly the second criteria there, you know, if we validate it the first 5 times that it's done and it comes out great, can we consider it to be validated? Absolutely. Again, keep a record of that, and it's fine until your software changes or you update that calculation. And once that calculation gets updated, you have to validate it again.
What would you do if your 6-month water bath thermometer correction is different enough from the previous to make the previous set point out of spec? You wouldn't know when over those 6 months it happened in order to qualify any data.
So depending on what that verification is, you might want to throw your thermometer out and start fresh. There's a lot of things in life that, once we find something, we can't go back and fix things. So from that point forward, we would move forward. That would be one. I mean, if it's drastic, if we're talking like drastically here, you might want to verify that data. If it's a huge difference. If it's just a little bit, just move forward with it from that point. Again, if there's a significant difference between the two, it's probably time to replace that particular thermometer.
Okay, for pipette verification quarterly requirement, does it have to be strictly every 3 months, or will once within the quarter be acceptable?
Oh, it's like annual. What does annual mean, Michelle? It's not specified down to the date on every 3 months. You do get some flexibility in that. Here's what I will tell you. If let's say we're doing January to March is one, and then March to June is the next one. We don't want you to do it, in January, February, March, and then again, at the end of March and the beginning of April. We're not looking for that. You want to space it out over that 3 months to where we're following within reason within those 3-month time frames. So if you're off by a week, likely nobody's going to throw a fit. If you're DOD, that might be a different story. But for generally speaking, that's not something we're going to track down to the day and say, oh, you were 2 days late on that. It's no good. No, you get some flexibility there, but be reasonable again in how you interpret that.
During audits, we were written up for not certifying temperatures at the use temp, not within 10-degree range. For example, TSS oven thermometer has to be checked against NIST certified thermometer at 104 degrees, the midpoint of use range. Our NIST was calibrated at 105 degrees. Could you clarify?
So it's within the range of use is how the standard is written. So again, this is something that when you have a finding like that sometimes it's well to push back and say after the fact, say like, I don't agree with this deficiency because XYZ, and provide documentation. In this case, I mean, the standard does say within the range of use. So 103 to 105, the range is 103 to 105. 104 would be ideal, but if you checked it at 103 or 105, I don't see an issue there. You were within that range. What we don't want to see is you to say, I use it at 103 to 105, but I check I check the temperature at 100 degrees. That's not within your range of use. And that's typically where we see an issue. So I would personally say that likely I would feel that the assessor was overutilizing the standard at that point to say the mid-range had to be utilized. It just says within the range of use. So I got nothing. I'm sorry.
For data review processes and different levels thereof, based on your experiences and observation, please describe and what are the ideal levels of data review? Who should perform them and the scope of the review for each level that you can recommend?
Ooh, that's a big old process right there. I will summarize and simplify for you as good as possible. Again, it's going to depend on the size of your laboratory and the amount of data flowing through. What it's going to look like for a commercial laboratory that gets thousands of samples a month versus the municipal laboratory that has a handful is going to be extremely different. So what we always would expect and hope and should very well happen is that your analyst who analyzes the data does that initial review of the data. And so that initial review always takes place. After that, there does need to be some sort of a secondary review that happens, and how frequently, how detailed that is, you can define that through your data review procedures. But generally, we want a second set of eyes to look at that data. It could be a peer, it could be the supervisor, it could be the quality manager. It's going to depend on the size of your laboratory and how things flow through, or your LIMS system and how that all flows through as well. When we look at the in-depth data monitoring, so there you've got your very simplistic, your day-to-day, I ran it, I looked at it, I made sure it passed, somebody else ran it, or somebody else looked at it, and then we've got that review that happens, life goes on. You also have to do that in-depth data review. How frequently that happens and how much is going to happen is going to depend on the laboratory itself. In some instances, I see that, with every batch that goes through, the quality manager actually reviews everything. Generally speaking, that lab's been in trouble before. And it's also a small laboratory that doesn't have a lot of work going through. In a larger environment, they're generally shooting for something like a 10% or a 20% of all data will have that in-depth data monitoring that happens. It's someone we frequently see with those larger commercial laboratories. The QC gets reviewed every time. So the analyst reviews everything. You know, the peer review might review everything. When it gets to that higher level, then they're looking at, you know, on a regular basis, did that quality control pass? Was the calibration good? That sort of thing. And then, and that defined criteria, you say, I looked at it in more in depth, and these are the things that I reviewed. You know, that's when you go back and make sure that the traceability was all there, that the standard prep was recorded properly, and that everything happened along those lines. You don't necessarily have to do that with every sample, but again, you get to define that within your system, and we want to make sure that it's reasonable. And there's a record, folks. Remember to keep that record.
Great. The accuracy of our NIST reference is to a 0.1 degree C, but the blood bank therms have an accuracy of 0.5 to 1 degree C. If the agreement is still within 1 degree C, is a correction still applied?
Wow, now we're talking about. Just so you know, I am not a medical person, folks, and blood banks generally have they have like their own ISO requirements. So it's really kind of outside of my realm. So in our realm, I'm not going to speak to blood banks, but in our realm, if there's a correction factor, it does need to be applied. Again, it's going to depend. So if it's plus or minus 0.1 degrees and you've got one, you know, 5.5 to 1, I would say that you could probably write that correction factor off. You know, if you're looking at it, say, let's make it a little bit simpler. We've got a refrigerator, you know, and so we record our refrigerator temperatures hopefully in whole degrees, right? And there's a rounding point. We have a rounding point that we all agree with in the laboratory. If it's at the halfway point, we're going to round up to the next degree. But then we're not that 0.1 degrees. If you check your thermometer, it's supposed to say 4, it says 4.1. Does that really matter, that correction factor? No, there needs to be a record of it and a decision factor that happens. They talk about that frequently in ISOs, those decision factors. Does that correction factor actually impact our data? In the case of a refrigerator, or in this case, you know, with a 0.5 degree, likely not. If you're looking at a micro thermometer, 0.1 degrees is big, and it does matter. My opinions on that are a completely different story, but it does incredibly matter under regulations and EPA methods that, you know, 35 plus or minus 0.5, that 0.1 degrees could push you out if you're looking at a 0.5 degree requirement. So just things to keep in mind. It's the accuracy in making those decision factors based off of what needs to be done in your laboratory.
Okay, we're running a little low on time, so I'm going to combine these two questions since they're both kind of about verifications. Do we need to verify the calibration if an auto diluter is built within the instrument internally? And then do burettes that are part of an auto titrator need to be verified quarterly?
Okay, so then we're talking about the automatic instrumentation thing. So pipette or burettes, yes. Auto titrators must be verified on a quarterly basis. That would be the same, folks, if you have it used to be Class A burettes. We used to, like, if you're doing like the old fashioned titrations, right? You got the one on the stand and you're turning it by hand. At one point, it was said that you had to check those quarterly. Under the new standard and the wording, that can be done when it's brought into use. And then I'm going to look at, you know, is your tip broken? If something changed, you would need to recheck. The auto titrators absolutely have to be checked on a quarterly basis. It's just part of you know, it's mechanical. In regards to the instrument, so if you have like an ICP with an auto diluter, an AA, like a seal with an auto diluter, so it does have to be checked on a quarterly basis. The level of that check is going to be very dependent on what location where you are located. So I will tell you from my experience in Florida, that has been deemed that it must be checked to the accuracy level of, you know, I actually have to perform a separate check. In other states, they might say, hey, I performed a calibration and it passed, so that's acceptable. So I'm not sure where we're at in California and how they feel about that and where that falls. That may be a TPA question. I haven't done enough assessments in California to have a feel for where that is, but we want to make sure that we can point to something and say, I verified it and it's still accurate.
Okay, this is going to be our last one, but I think it's a really great one, especially for a lot of our labs. It says for a one-person lab that handles the samples from cradle to grave, what do you recommend to clarify free from conflict and undue stress when that one person wears multiple hats?
Well, you know, we do have a handful of one-person labs there in California, as we do anywhere else. So the thing I would tell you is to include as many safeguards as you can. It happens, and we're not going to judge you for it, you know. So when you review data, you know, set it aside for a while and come back and review it later. When you're doing that internal audit, let us know how you're going to go about being impartial and try to look at things through a new eye. So you're just going to write it into your quality system, how you're going to give yourself that that added benefit. It can be things like using a checklist. So rather than I visually just walked down through it and I signed off on it twice, maybe there's actually a checklist. So I reviewed it the first time and then I use a checklist and said, these are the criteria that have to be met. And then I'm signing off on that. The same with internal audits. If we're looking at, how do I not audit my own material if I'm a one-person lab or if I'm specialized? I talked about that during the big training was that, you don't necessarily want the microbiologist to do an internal audit on the organic chemistry data. It does not work. They don't understand each other. They speak different languages. It's like trying to talk to an engineer or an IT person. We just don't speak the same language. So in that case, you need to make sure, like, how are you going to go about that? Again, checklists are a great way to do it that you can point to and say, I filled out every one of these lines and I evaluated the data and then I signed off on it. And that's how I kept myself, from being overly familiar with my data. And just do the best you can, document it in your system, and hopefully it'll work.
Awesome. Well, thank you so much, Michelle, for all that helpful information and taking time to answer as many questions as we got through and share your wisdom with us. Michelle is working on getting on Slack so that she can be there to answer a couple more questions if you guys have some for her. And we apologize to the people we did not get to. We will have staff trying to do our best to answer some of those questions that are left in the Q&A chat box. And as Michelle mentioned early on in her presentation, ELAP has received the videos of the training workshops, and we'll be posting those to our Roadmap to Accreditation webpage soon. And with that, we are going to have one last presentation. As Program Manager of California ELAP, Christine Sotelo has worked in environmental and public health protection for over 20 years. She has expertise in water quality monitoring and assessment, municipal stormwater program permitting and auditing, water quality investigations and multi-agency enforcement actions, California Environmental Quality Act compliance, emergency response management, public participation, and environmental justice. Here to send us off with our final presentation is Christine.
So good morning, everyone. Thank you so much for joining us at ELAPCon this year. This is going to be a hard act to follow. Michelle just blows my mind on how much she knows about TNI and assessing laboratories, but I'll give it a shot. So I feel really lucky to leave you with some final thoughts and to be able to close out this conference with a very warm bon voyage. So for those of you new to this conference or to California ELAP, I'm Christine Sotelo, the program manager, and we're happy to bring this conference to our lab community this week. When I first entered the environmental laboratory testing space in 2014, I noticed a gap in outreach and education, actually a gaping hole in how we communicated with our laboratory community. And so began the vision to create a forum where we could share knowledge and compliance assistance, given our front row view of environmental testing industry. It makes our ELAP team so happy to deliver this conference to you this week. Next slide. Next slide. So silent gratitude isn't very much to anyone, and a quote from Gertrude Stein. So I want to start by saying some very public thank yous, especially to the wonderful presenters who joined us this week. We covered a variety of topics during the conference aimed at helping improve and lift up our laboratories in many ways, and we're fortunate to have so many incredible presenters volunteer to be part of our program this year. We heard about Lean Six Sigma and checklists, emotional intelligence, cybersecurity, ethics and integrity, and to top it off, the TNI standard training from Michelle. I want to give a special thank you to CSEA for helping us with our day one programming and focusing on laboratory essentials. The feedback I received has been incredibly positive about growing CSEA as an organization in California. So many of you expressed thanks to be able to learn about laboratory basics and learning about the history of environmental testing labs and how you're looking forward to supporting CSEA's mission. And I would be remiss if I didn't give a huge thank you to ELAPCon planning team that put a ton of hard work to make this possible, especially co-chairs Jen McLaren and Catlin Bloom. and Leanne Castle for her hard work directing the technical aspects behind the scenes, and all the ELAP team members who contributed in supporting roles. And finally, a thank you to you, the laboratory community. This conference is for you, and we couldn't do it without you. Thank you for spending your incredibly valuable time with us this week. So I wanted to talk about raising the tide and our goal this year as it encompasses this year's theme. We wanted to create a program to lift up the whole laboratory community, from the analyst at the bench to the laboratory director. We wanted to provide opportunities for personal development and help laboratories comply with regulations. So I hope that in joining us this week, you guys felt the tide lifting you up to be the best laboratories you could possibly be. Next slide. So I presented this slide last year at ELAPCon, and I want to revisit it. It's the regulatory loop. We all have shared responsibilities, and we can't exist without each other. Labs like yours generate the data, uphold scientific integrity. ELAP's required to accredit labs used in California, and regulators decide the methods that meets their monitoring and data quality objectives. So this loop is really important, and I just wanted to make sure we all understood our shared responsibilities. So if there's one thing I hope we can agree on after this year's conference, is that we all have room to improve. So I want to tell you about what ELAP is going to do to continuously improve. Next slide. So our plans are here, and I want to highlight a few of the things I'm directing the ELAP team to take on over the next year, both externally as well as internally. Compared with last year, we have a lot more information about where labs are struggling. We have also had a lot of productive conversations over the last year with individual labs and groups of labs that have led to this announcement, which is that we'll shortly launch phase 2 of a roadmap to ELAP Accreditation Compliance Assistance Initiative. Phase 1 focused on T&I because that's what you asked for. And phase 2 is a shift towards helping you comply with the regulations for PTs, assessments, and applications. We're still seeing a lot of problems with our PT testing, compliance monitoring, and assessment timing. We've learned about a third of labs are not completing assessments in time to apply and must be put on a corrective action plan. We're planning videos, planning tools, infographics, and monthly Ask ELAP sessions where you can come ask open questions. We want to be better for you. And to that end, we're looking at all our processes and committing to reducing the time it takes ELAP to perform assessments by going through the Lean Six Sigma program, which you learned about earlier this week. We're going to walk the walk and begin a project for process improvement ourselves. And finally, our plan is to strengthen the regulatory loop. We are often the middleman or the messenger between the regulators and the labs. And so we want to help strengthen the relationships between you, the laboratories, and the regulators. So I've been active on Slack for those of you that are on there. And one of the questions that I got from someone is, where do I see ELAP in the future and in the next 10 years? So I'm hoping that person I was conversing with on Slack is listening today. So where I see ELAP in the next 10 years is that I see a lot of change in the industry, and it's going to normalize after adoption of the new regulations. And this is to be expected with any new regulations. I also see rising expectations of the laboratory community because there's increased regulator involvement. The state agencies' expectations continue to change as they become more fluent and conversant in laboratory operations and data quality, and you as a laboratory community will need to adapt to them. Gone are the days when data was accepted without question. I also see in the next 10 years us providing more compliance assistance, and will continue to provide tools and assistance to help laboratories succeed. But to be clear, what the agencies are telling me is that they want quality over quantity. So only high quality laboratories can protect the environment and public health. To that end, and because we want you all to succeed, ELAP is providing as much help as we can to help you in the future. So where do I see the program beyond 10 years? I'd like to see California accreditation become synonymous with the adjective elite. We will have elite quality labs at all levels, whether you're a municipal lab or a commercial lab serving our state. I also see us as a community in ELAP becoming more adaptable and nimble in how we implement our program and how our laboratories operate. We're at the forefront of environmental monitoring here in California, and California is often first in the nation. And if you've been keeping up, we're the first in the world to offer microplastics accreditation. And our labs will be the first to run new methods, and ELAP will be able to quickly accredit new methods because regulators will push us to be the best in the nation and in the world with new methodologies and offerings. And I also see us continuing to keep each other mutually accountable. We're in this together and we expect high quality out of each other, and we help each other achieve it, even though these conversations are unpleasant at times. We're currently working on a dashboard to publicly publish our operating metrics because we value transparency. Next slide. So I want to leave you with a message and a challenge to strive to be the best labs producing the highest quality data for California. And I hope that some of the presentations this week will help you do that. In other words, and to continue this year's nautical theme, go find your sea legs and know that we'll be here to help lift you up with the tide. Thank you for joining us, and bon voyage, everyone. We'll see you next year.
Well, that is all we have for this year's conference. We would like to take a minute to thank all of our presenters for their time, energy, and talent that they've shared with us. I would also like to thank each of you who attended either all or some of the days of the conference. It's our hope that you found this conference helpful and inspiring. I would be remiss if I didn't take a minute to thank all the faces that you don't see so often on your screen. My lovely co-chair, Catlin Bloom, our incredible technological producer, Leanne Castle, and our Q&A masters, Chris Hand and Caitlin Hilty. And of course, none of this would be possible without Christine's leadership. This is truly a group effort to make this event possible. If you registered for the conference through Eventbrite, please keep an eye on your inbox in the coming days for a feedback survey from us. We would love to hear your thoughts about this year's conference and start getting your input for next year. And again, thank you for being here. And until 2023, bon voyage.